What's going on, everybody? How we doing? You want to learn how to play KSP? I can do that. We can figure that out. We can figure that out if you want. How's everybody doing? I fly. I'm pilot. How's everybody doing? YouTube, you guys over there good? All right, so today I'm I was thinking we'd do... You know, I did a little bit of a tutorial on the Monday after...
Discovery, go at throttle up.
After Artemis 2, and I kind of just showed how to launch. I didn't really show how to, like, make the vehicle or anything. So... I think I'll kind of go through for the newer Kerbal players, right? If you're pumped from Artemis 2 and stuff, right? You'll come in here and maybe learn a couple of things here. The alerter is working. Yes, Hooch, 20-month resub. Thank you. I think we need a full KSP refresh tutorial. Yeah. Yeah, probably something like that. Jim, you were just catching up on last night's VOD. Seems Blue Origin launched NG3 KSP style is in press space and hope for the best. The more I think about that, dude, the more I'm really not too happy about what happened there. No distractions and no car lift surprises today. Yeah. Mixed vibes from that congressional hearing. That's actually why I'm late. I was listening to it. Yeah, I'm not, I do like a lot of the things that Jared Isaacman's doing, but, you know, I'm not gonna be like, oh, I hate the guy. Like, no. Yeah, like, the whole thing with SLS is not, I really, you know, like, even canceling the EUS is not, like, I don't think that's a good idea. And the reason why I don't think it's a good idea isn't because, like, oh, I love the... what the heck is that? Hey, Pruitt, I'm good. Hope you're recovering from your chip coverage. I'm trying to take it easy this week. Just a little bit. Just trying to take it a little bit easier. Guys, I don't think that standardizing SLS around a Centaur is a good idea. Yeah, I've had some time to think about it. I just... Now... Once again, it's not that, in theory, that's a bad idea. It's just really comes from the whole kit bashing rockets thing. You don't really kit bash rockets. It's not like what you're about to see in Kerbal, right? Like, it's not really how that works. Like, I'll show you in KSP. You could just take one stage and put it on top of another, call it a day. Right? But, yeah. I don't know. Maybe we'll talk about that later. The EUS and the core stage have similar tooling, so Machine would have an easier time to scale. Yeah, that's really my thing. I really think that would be an easier thing, just to go forward and just use the dang thing. Like, I really would have just, what's the right way to say it? I don't mind having, like, a Centaur upper stage, but I would use the last ICPS to still do an Artemis 3 style mission. Like Artemis 3, like what they want to do, like a high Earth orbit mission or something. That would be fine. And I would really push to standardize around the EUS. I think that's a better idea. I really, guys, the more I think about it, the more, like, all right, keep in mind, I have like a surface level understanding here of this, but like, take a look here. So the upper stage that he wants to put on SLS is a Vulcan upper stage. So that's Centaur 5. Now Centaur 5 is a great upper stage. Like, don't get me wrong, really, really good. But okay, so if we look down here, capabilities, right? You have your Vulcan VC6. Okay, so this is low Earth orbit, so the ISS, right? You don't, that is kind of representative. The VC6 upgrade is kind of representative of the biggest payload that you could proverbially put on a Vulcan, right? It's 26,900 kilos, or about 59,300 pounds. That's, the Orion is 36 tons. With its launch abort system. Dudes, there's no way that they don't know this. Like, that's where I'm kind of getting a little confused here. There's no way they don't know that. You can't put 36 tons of payload on top of a stage that's only designed on the upper levels for maybe 30, maybe, because, you know, always a little bit of margin, right? That's not going to work without some serious redesign of the stage structurally to be able to handle it, or you'd have to do a forward load reactor. Now, if we look at an Atlas V 500, take a look. So an Atlas V 500 has a Centaur. It has a Centaur 3, which is a different design, but it's still manufactured in a very similar way. Oh, that's Atlas V 400. I don't want 400. I want 500. So if we look at 500, right? The bottom of the Centaur is sitting inside of a cylindric interstage adapter, right? The stage sits on this piece right here. But Centaur cannot hold, because it really is not designed to hold a much bigger payload on it. On Atlas V, their solution was to have the fairing carry some of their structural load by these C-shaped things right there. ULA calls that the Centaur Forward Load Reactor, or CFLR. This is basically a brace to hold the upper stage, hold the top of the Centaur in position, because it can't take that heavy of a satellite. If you just put that heavy of a satellite up there with a fairing, it would crush the thing. That's why Atlas V has two variants, Atlas V 500 and Atlas V 400. The 400 variant of Atlas V does not have, right? See, that's just a regular fairing with a much smaller payload, right? So that's a Centaur 3, though, so it's a little bit different, but it more or less is the same idea. The reason why is because it's made similar. Like, this is just a different shape, but it's very similar in construction. It's using stainless. It uses stainless steel that's maybe as thick as a piece of paper. Centaur is a balloon-style tank. It relies on pressure to hold itself up. And that's only going to get you so far. If you put too heavy of a payload on it, it'll blow it up. It'll just fall over. Or if it loses pressure or whatever. Now, if you look at Vulcan, once again, Vulcan... Yeah, Kai, I'm getting to that. Vulcan has two BE4s in it, right? And you could have up to 6 GEM63XLs, which make... let me think. The maximum thrust of twin BE4s is about 5 meganewtons right there, or about 1.1 million pounds of thrust, right? And then you could have up to 6 GEM63s. All right, that pushes your thrust an additional almost 2.8 million pounds, or 12.3 meganewtons. All right, so we're looking at an upper level load here for Centaur with a 26-ton payload on top in the upgraded version, right? You're looking at an upper level of about 20 meganewtons of thrust pushing up on that thing, right? So 6 GEM63s, 2 BE4s, heaviest version, right? With maybe a 26-ton payload up at the top. Or let's say 27, okay? So Orion's 36 with its launch abort system, with the LAS. It's 36. And putting a Centaur on top of an SLS core stage, you know, that's not 20 meganewtons pushing up on it, okay? That's not 20 meganewtons pushing up on it. You know, the combination of 6 SRBs and 2 BE4s. You have 4 shuttle engines and 2 5-segment SRBs, right? That's 35 meganewtons, not 20, or about 8.8 million pounds of thrust. Dude, look, I know enough about this to know that there's no way that ULA designed that stage with a load factor of 3x. Well, it actually would be like 2.5 times, or 2 times the load factor. There's no way that it was engineered like that. Like, meaning that, oh, the maximum payload that we want to put on this thing is 27 tons, so let's rate it for 40, right? There's no way you'd over-engineer that much. You can't, because it's balloon tanks. Like, once again, stainless steel. Dude, Centaur's outer tank wall are about as thin as a piece of paper. Maybe a piece of construction paper. It's about that thin. There's only so much you can put on top of that before it pops. Hey, Red Panda. The SLS puts it already into orbit before separation. I don't understand how that has any bearing on what I'm saying, but yes, that's good. Hey, Red, what's going on? The limit may not be structural. Oh, no, it is. No, it is. I'm like 95% sure at least. Just playing some KSP? Right on. How much of that payload capacity is due to the limits of the Vulcan first stage? Well, of course you're limited by your liftoff thrust rares, but you're not going to design something for a super heavy launch vehicle and put it on your heavy launch vehicle and be like, yeah, it's good. You know, like, that's... I'm pumped about Artemis 2, and I do want to get back into KSP. How did you know? Oh, I just had a feeling, dude. Hey, Beats, I'm good. So, like, yeah, I that's not to say that you couldn't put a Centaur up on top of SLS. Of course you could. You know? You absolutely could. But you would need to do something like this. I am 95% sure of this. Like I said, could be wrong. Could be wrong. But the adapter that you're going to need to adapt the core stage to a Centaur 5 with an Orion on top of it is going... I'm pretty sure you need a forward load reactor. Like, I wouldn't put my foot down like this and be like, no, unless I was pretty dang sure. You know? So you think the EUS would have comparable engineering time to get Centaur 5 going? Genuine question. Well, JP, here's what I'm getting at. I don't know, to be 100% honest with you. I don't know. But I know that designing an adapter, I'm fairly confident that the amount of time it would take to design the adapter for Centaur to work on top of SLS with an Orion, it probably wouldn't take as much time as designing the entire EUS. But I'm fairly confident it would take the amount of time left that they have to get the EUS working. Like, say like getting the EUS, like, even to, like, one flight ready to go takes another year before we have one that we could put on top of an SLS, right? I can guarantee you that a Centaur adapter is going to take that amount of time. You're completely changing the load. You have to completely change the load path of the Centaur. Like, it was not designed to be on top of a super heavy launch vehicle. Once again, like, dudes, I'm not, like, I haven't done much crazy analysis about this, but that, like, I do know physics. Balloon tanks can only take so much. Hey, Ren, what's going on? No, not really. We haven't learned much about how SpaceX is going to deal with boil-off. My guess is just header tanks. Modifying the DCSS to make the ICPS took 5 years. Yeah, Nova, that's what I'm saying. Like, if we can work hard and bust out a forward load reactor for Centaur 5 and have that ready by 2028, then okay. I will. That's what I mean about that 5% margin. It's not undoable. But my question, honestly, at this point, is that why? Why would you do that? Just finish the EUS. It'll take the same amount of time. I don't know. It's just something I've been thinking about, dudes. To be 100% honest with you, I don't really care. Like, the EUS would, I think, be better in the long term. The Centaur would probably be better in the short term. Like, either one will work. I'm just, like, the point that I'm trying to illustrate is that it's not, you can't just put a Centaur up there. Like, it's not like you just need to design another cone, put Centaur on top of that, and stack Orion on top of that. That's, there is a very good reason. There's a very good reason why the Apollo program originally thought using a Centaur for your upper stage to move your lander and your CSM out to the moon was a good idea, and then they promptly said, no. Nope, that's dumb, and then switched to the S4B. There's a very good reason for this. The reason is because the Centaur, you can't put a lot on top of it. It'll crumple. So GS2 is the answer? Huggy, that would be a good idea. I think a cut down GS2 might not be the stupidest idea. Like a shortened one. You could shorten it. That would be relatively quick and easy to do. Yeah. I would say, like, take a GS2 and make it half the size. Seriously, just make it half the size. And then put a single B3U behind it. That'd be fine. That'd work. That'd work great, actually. But yeah, GS2 is not playing nice either. Hey, human. All right, let's go. Let's get into the tutorial. Just a little opening remarks, we'll say. Kind of takes a second to get into the groove. So, you want to learn how to play Kerbal. All right, here we go. Let me get some tunage going in the background. And I will go into my engineering mode save here. So, my engineering mode is just a straight sandbox. A lot of people ask me, like, where should I start with Kerbal? How should I do this? Where should I start? You could play the career if you want to. That's kind of throwing yourself a little bit into the fire. Okay, we're in engineering mode 22. All right, that's kind of throwing yourself a little bit into the fire here. So you don't, without understanding like a lot of the terminology here in KSP, career mode is going to be a little bit strange. So what I'm going to do here is kind of this is my sandbox save. This is where I use to make funky contraptions. I just make whatever in this. This is my screw around save. Like it's a fun save to play. I have a lot of weird creations in here. I have a ton of craft files loaded into the save. You can tell because it's taking forever to load it. That's cool, human. I make all kinds of cool stuff, from like little airplanes to rockets to whatever. Okay, so let me kind of run everybody down here as to what all this means. So in Kerbal, you have a lot of different parts. There's all this different stuff, and you might be a little bit overwhelmed popping in here. Like what? If you're in a sandbox save like this, what are we doing? Well, I don't know what any of this does. That's fair. All right. Hey, Ozzy, what's going on, man? We are so back, dude. We are so back. All right. So no, I haven't, John. All right. So up here you have pods. Pods are the things that carry Kerbals. All right. You have everything from a seat. You can literally just give the Kerbal a seat that they sit in and launch them into space, or you could give them different types of we'll call them command modules, right? Now, you have all the different types of command modules here, and if you want to see, like if you want some information about the command module, you'd right click on it. It holds the window, and it'll tell you a bunch of different things about it, right? With a little, blurb about it and whatnot. Crew capacity is right there. The Mark 1 command pod here is something similar to a Mercury capsule. It's just a one-seater pod. Pretty good. You have that, and you could do anything up to, well, that one you kind of, I think you guys know what that is. So you have a shuttle style thing. You have an Apollo style capsule here. There's even, if you have the Making History expansion, there's even a little Gemini style capsule as well. So you have pods, but there's also probe cores. Okay, the probe cores are down here. These probe cores are stuff that you can use for land, like remote landers, rovers. Like for a rover, you have the Rove Mate here, right? The Probodobodyne Rove Mate, and you can, like, oh look, you can make rovers with them, right? You put science equipment on it, etc., etc. Send that wherever you want, right? Then you have little probe cores. These probe cores are, for the most part, your avionics package. Now, what's the difference between all these probe cores? Well, these probe cores, some of them have more capability than others. Some of them can do more things up in space. Some of them have a better antenna, etc., etc. But that's kind of the pod category in a nutshell. This is all the stuff that you need to command and control things. Now you go to the next one here. This is fuel tanks. That's pretty straightforward. They're fuel tanks. Now some tanks hold different commodities here. In rocket science, commodities, does the ejector seat work? There's no ejector seat in stock KSP. You'd have to make one by attaching a bunch of rocket engines to the seat. It's doable. Now, commodities in... And once again, feel free to ask questions if you have questions here, dudes. I'll if you don't know me, I have 20,000 hours in Kerbal, at least. I will most likely know the answer. So, commodities in spaceflight are basically any type of consumable. It could be in real life, it could be anything like water. Like people need water, you gotta drink that. To all the way to rocket fuel, right? Or somewhere in between, like hydrogen and oxygen. Now, in real life, you have different types of rocket fuel. There's kerosene, there's liquid hydrogen, there's liquid methane. In Kerbal, you don't have any of that. You have one type of fuel for the most part. It's called liquid fuel. Like if you click on a fuel tank and then right click on it again, you can see what it has in it. It has liquid fuel and oxidizer. And then if you want a little bit of a window here as to what each thing carries, you know, right click on it and it'll pin this window and you can see what's in it and stuff, right? Toughest time I'm having starting my career is making that rolling thing you use to get to the VAB tracking stations. Oh, the lizard? I've got 2,000 hours in KSP. Is that good? Sure. All right, so, hey, Shark Tales. 6-month resub.
Go at throttle up.
All right, so you have liquid fuel, you have oxidizer, and then there's also these. These are called RCS fuel tanks. They carry a commodity called monopropellant. We'll talk more about that in a little bit. There's also ore tanks that carry ore. That's for a little bit later. And then there's also regular just fuel tanks that hold only liquid fuel. These fuel tanks are more used for like airplanes and stuff, because the jet engines in the game use liquid fuel and the rocket engines in the game use liquid fuel, right? Hey, Pickled One. So that's a little bit on fuel tanks. You also have the fuel drain valve, so you can dump fuel if you want to. And then there's the external fuel duct. The fuel duct is a fuel line that you can use to connect two fuel tanks together to get one fuel tank to flow into the other. Now, it's important to note that if you stack a fuel tank one on top of the other, like this, it will drain. You can check it by clicking on the fuel drain overlay, right? If you right click on the tank, hit fuel delivery overlay, it'll show you the plumbing. Okay, you don't necessarily need the fuel line to connect all your tanks together. They'll just automatically connect. That is something that Kerbal does abstract a little bit. In reality, rocket fuel tanks have complex plumbing to be able to transfer the fuel and oxidizer to the engines. It looks like a pipe organ inside of a lot of rockets. Yeah. So, that's fuel tanks in a nutshell here. There's also one more commodity that I didn't mention called xenon. Xenon gas. But we'll get into that. We can get into that in a little bit. Now, the next category is engines. This one should be pretty straightforward. So here, let me attach a fuel tank here. Or let me place down a fuel tank. Actually, you know what? We'll place down a probe core. Let me just get the basic probe core. That's the most basic one. And then we'll put a fuel tank behind that, right? And then we put a engine behind that. So, there's a couple of different engines in this game here. Obviously, there's jet engines, right? That I don't think I need to say what that does. Jet engines work. They're jet engines. If you want them, you can make airplanes in this game. You can make them to fly around. More importantly, you can make airplanes that fly up into space if you really know what you're doing. And even crazier is that in Kerbal solar system, there is other planets with breathable atmospheres in this solar system. Kerbal solar system is not analogous to our solar system. It's not exactly the same. It's close, but it's not exactly the same. There are other planets, and I won't say which ones. There are other planets that have breathable atmospheres that you can send jet planes to. But jet engines, for the most part, don't work in space. Well, actually, not for the most part. They don't. They don't work in space. These things need air. You have to have oxygen in your atmosphere for this to work. So this won't work up in space. It'll only work down near the surface relative to Kerbin, right? Now you do have different types of jet engines. You know, there's the Whiplash engine, which is an SR-71 engine. That's a J-58. And note that the engine is only the it's only the nozzle for the most part, but that is a turbo ramjet. So if you wanted to make something like an SR-71 and fly it up into space in Kerbal, yeah, you could get away with that. There's also the Panther engine. Panther engine has thrust vectoring, so it can. You wanted to make something like an Su-35 or something, you could do that if you really wanted to. Right? There's also tiny jet engines, like the little Juno engine, which is just a little turbojet. You can basically make whatever you want, but so you got jet engines. Jet engines only use liquid fuel. Then you have rocket engines. Let's take the LVT-45. This is one of my favorite engines in the game. Actually, this is one of my favorite basic engines. The LVT-45 uses liquid fuel and oxidizer, okay? So, right here, we kind of have all the ingredients to go up, so to speak. All right. Now, remember I told you could show your fuel delivery overlay here, okay? Simultaneously, if you click on a rocket, you have that fuel delivery overlay option as well. This rocket will pull fuel from this tank. It will pull liquid fuel and oxidizer. So let me show you what happens when we do this. Hey, Jared, the laws of physics and engineering any different in the Kerbal universe? Physics is more or less the same, surely, with some abstractions. Aerodynamics in Kerbal is very simplified, but it's good enough to get the point across if you're learning. So, we have this out here. We want the rocket engine to rocket engine. So, you have your throttle indicator right here. See that? That's your throttle. You can hit Z on the keyboard to make it go to full. Left control will bring the throttle down. Right control brings the throttle up. Z is full power. X is cut the engine. So, notice how I'm throttling the thing up. It's not doing anything right now. Well, that's because the engine isn't on. You have to turn the engine on. So you could do that over here. Over there is your staging window. Okay? Staging window tells you if the engine is on. So if I activate the engine with no throttle, see, the fuel gauge popped up over there. That's important to know. Fuel gauge popped up. That tells you how much fuel is left in the stage here. All right, we have a full tank of gas. That's what it's showing. And it shows that that engine is on. If you want to see what engine you've activated, you hold your mouse over it, it'll highlight the part. If you right click on that, it'll show you what's called a part action window. I was showing you guys the part action windows in the editor. PAWs for short. This will tell you if the engine's on, how much thrust it's making, etc., but you can just look at the gauge over there. Now, what happens if we hit Z? Whoop! There we go. Flying. That's pretty neat. Uh-oh. Uh-oh. Well, that's a problem. Yeah, it turns out having a brick for the front of the rocket, not very aerodynamic. Now, I did cut the engine, right? I mean, whether it doesn't really matter, but I like launching out of the SPH because the SPH is easier. But yeah, we could put it on the pad, but it doesn't really matter. So note that it's coming down, but our engine is still going. What's going on is that, well, the front of our rocket is not very aerodynamic. All right, we're gonna have to fix that. Yeah, see, it doesn't like it. What's happening here is because the front of the rocket is not very sleek, right? It's creating a ton of drag up at the front of the vehicle. And eventually the pressure gets so high, the dynamic pressure at the front of the vehicle gets so high that it actually creates a what's called a moment force that's going to flip the vehicle over. Basically, you think of it like if you have a freight train, like a freight train derails. Say the engineers jumped off and the freight train is derailing, right? If you have something stopping the train at the front, it's going to try to accordion itself, right? We don't want that. So instead of the rocket accordioning itself, it's just gonna fishtail, so to speak. So see, you can't really see it, but our dynamic pressure went up really high. And see, it flips it around. There we go, we're out of fuel. Right? This is the general gist of how this all works, right? You have your probe core up at the top, you have a stage, or your fuel tank, and then you have the engine behind it, right? Pretty straightforward, guys. It's not tough. Like, that made it a good distance. If you want to see how far your rocket went or how fast you went, you can hit F3. And F3 is kind of your stats menu here. Highest altitude achieved, 8,600 meters. Highest speed achieved, about 376 meters a second. Most Gs, 9.7 Gs. Like, the F3 menu will give you a little bit of stats here. But if you notice, we're coming back down. Kerbin, this planet, has gravity that's similar to Earth's. So gravity is pulling us down. What goes up must come down. I don't have any parachutes. I didn't put any parachutes into this design. We don't have any fuel left to slow down, so that should have blown up, but probably some weird setting with one of the mods that I have. That should have exploded. Just pretend it exploded. For fun. As a treat. Should have popped. I'm gonna have to go look at the difficulty settings again. The freaking Jello water, man. So I have a mod that makes the water look a little bit nicer, but it also makes the water like Jello instead of like, if you hit water at high speed in real life, it acts more like concrete than it does Jello. But whatever. You get the idea. If it was any other occasion, if that was your save, it would have blown up. All right? There's always room for Jello. So let's make this a little bit more aerodynamic, shall we? We got to do something. We got to put something up at the top here. So, right, the third window. Let's get into the third window here before we do another test flight. The third window here is command and control. These are gyroscopes and smaller thrusters to help you maneuver around. Now, on real spacecraft, you got little tiny rocket engines to help you maneuver. These little tiny things are called RCS, or reaction control systems. They're not necessarily found on a lot of first stages, unless it's like Falcon 9 or New Glenn or something. But what these are is they're little tiny rocket engines that are used to maneuver you around. They're mostly found on second stages and spacecraft, for instance, right? If we look at, if you're pumped from Artemis 2, right? And we take a look at Orion, for instance. We look at Integrity. Here's a picture of Integrity before it launched here. All right. So this has covers on it and stuff, but if you look at Orion Integrity, see all these little guys? Those are little thrusters. Those little thrusters are there for a spacecraft to be able to maneuver around in space. We could go a little bit more into, you know, how RCS works later when we build a spacecraft. But once again, high-level overview of what everything does. Now, all these thrusters do use fuel, but to figure out what fuel they use, you got to right-click on them and it'll tell you what it used. Most of these use what's called monopropellant, okay? Now, on top of that, you have gyroscopes or inline reaction wheels. Real spacecraft do have reaction wheels, like the ISS has some of them. In real life, these are called CMGs or control moment gyros. A gyroscope uses angular momentum to get you to rotate. The Hubble Space Telescope has control moment gyros because it's orbiting around Earth, but it needs to be able to look, right? It needs to be able to look in one direction for a little bit of time to take the picture, right? Like how a photographer would set up a camera and be like, okay, I'm ready to go, right? Not every spacecraft has reaction wheels in it. Most spacecraft like Orion or the Space Shuttle or the Apollo CSM or Dragon use RCS to be able to maneuver around and rotate their position, right? But in Kerbal, you do have gyroscopes. The gyros are super useful. If you're a newer player, to help you kind of get oriented up in space. More advanced players, I would argue, don't really need them. But yeah, you do have control moment gyros and they will turn. Hey Nettings, thanks for the raid, buddy. All right. We don't need any of those. Okay? For this, because what we're going to do here is make a rocket that gets into space, right? Now, structural just has, well, as the name implies, it just has a bunch of structural pieces. These are not good. These are for more like advanced users. Like you wouldn't use this if you're just trying to get something into space. The reason why is because these structural parts are really, really heavy. They're all very, very high mass. They're very durable parts. You use them for like base building, or in my case, building launch pads, but that's another story. Now, if you have the Breaking Ground expansion, these are robotic parts. You have telescoping hydraulics, right? Or just regular hydraulics. You have hinges, you have rotors, you have servos. You can do all kinds of stuff with these. I won't get into that here, just doing a high level overview, right? Now, this is coupling. Coupling is very important to understand. These are where docking ports exist, so you could dock two craft together up in space. You know, if you have two of the same style docking port, they will magnetize up to each other and go. We also have these. You have claws here. Big, meaty claws. What do those do? Well, I don't have any quicker or any easier way to say it. There's asteroids in KSP. You got to find them. And this is for grabbing asteroids, so you can anchor a spaceship and or base to an asteroid and maneuver it around. The asteroids in KSP, if you have enough thrust, you can change their orbits. You can perturb them, right? Decoupler versus a stack separator. What is the difference? Sure. Early on, if playing with science unlocks, I don't know if you get access to RCS and monopropellant until after you get reaction wheels. It doesn't matter. Okay, so Postal, that's a good question. Now, down here, there's all different types of docking ports. Don't worry about engine plates. That's not relevant right now. So, a decoupler versus a stack separator. What's the difference? Good question. A stack separator. So look at the arrows, okay? When you separate a stack separator, okay? Now, the decoupler mechanisms are usually what's used when you do what's called staging, okay? So why do rockets, what is staging and why do rockets do that? Well, the short answer is that you need you need to go really fast to get up into space. And if you think, I'm just trying to get the right picture. Okay. The short answer is that you need to go fast to get up into space. You need to accelerate something in real life around Earth. You need to accelerate something to 17,500 miles an hour or 27,500 kilometers an hour. You got to be going pretty dang fast, right? And when you launch a rocket, you generally want to discard what you don't have because, or what's already been used. You generally want to discard like an empty fuel tank, for instance. So say you have like a big gigantic fuel tank that's enough fuel to get you into space, right? And you launch up into space. How much of that fuel tank is empty for the duration of the ascent, right? So what you do is you break it down into smaller pieces. So when you use up a certain amount of fuel, you can let that stage go and you could use another stage to go up there, to get up there. You have less mass. And to accelerate to that speed at certain parts, you don't need as much thrust. Like, let's look at a Saturn V, for instance. A Saturn V is probably one of the better examples of this. So if you look, Saturn V has 3 stages, okay? It has the S4B as your third stage, the S2 as your second stage, and the S1C as your first stage. This first stage is designed to get you up off the ground. That's designed to get you going up there. This one, the S2, is designed to go fast. That's what gets you to 17,500 miles an hour. The S4B, the third stage in this particular rocket scenario, is designed to accelerate you to about 24,000 miles an hour, or about 40,000 kph, somewhere around there. No, it's not 40,000. It's close enough. This is designed to get you to the moon. That one, you're going to the moon with this thing. And then you have your lander, and then you have your thing that carries people up there. Now, once again, if in rocket science, you could make this, you don't necessarily need the S2 and the S1C. You could make just the S21C beefy boy, right? And that would get you further, or it would get you up there, but it wouldn't get you as far. The reason why is because you're carrying all this extra crap with you up into space that you don't need. So rockets stage. They dump the parts that you don't need. You dump empty fuel tanks because when you're trying to accelerate something to 5 times the speed of a bullet, weight is at a premium. But remember, in rocket science, it's not weight, because you're going into a microgravity environment. So it's not weight, it's mass. Now, what is weight, just in case anybody really needs a refresher here? Weight is the gravitational acceleration on a mass. That's what your weight is, okay? Up in space, you don't have gravity pushing you down because you're going fast enough to fall around the Earth constantly, right? Because of this, it's mass. You're kind of not, you don't have Earth pulling you in. You're going fast enough to not have it pull you in, right? And it will pull you in if you don't get to 17,500 miles an hour or 27,500 kph. If you don't get there, you're coming back down. But up there, it's mass. So if you hear me say mass, I say dump the extra mass. That means that's making the vehicle less mass. So less mass, with less mass, you're basically discarding the dead weight. Like when I say you're discarding the dead weight, I'm saying that not because I don't know the difference. I'm saying that because it's easier to say it that way for people that don't necessarily understand rockets that are watching this, all right? So decouplers are used for staging. It's used for dumping tanks. That's what the decoupler does. And I'm getting to the difference between that and a stack separator. The main difference between a stack separator and a decoupler is if you look at the arrows on the decouplers, right? There's an up and a down arrow on a stack separator. There's just an up arrow on a decoupler, okay? So if we wanted to stage our rocket and we have our upper stage here, If we separated this decoupler, it would separate like that. The decoupler would stay. It would stay with this tank. It separates whatever's in front of it. Now the stack separator, a little bit different. If I hit this stack separator, note that arrows are pointing in both directions. If we hit the stack separator, what's going to happen is it's going to separate this tank. It's going to separate itself and itself as well. That's the big difference. Why use one over the other? I don't know. Depends on the design. What are you trying to do? Right? It's wild that over 80% of a rocket's weight is just fuel. Axax, it's actually, if you really want to know the exact thing, it's more like 90. Actually, it's closer to like 95 to 98% depending on the rocket. That's what I mean. That's the margins that we're talking about here to get into low Earth orbit. Your rocket needs to be mostly fuel, and by mostly, I mean all of it needs to be fuel.
Discovery, go at throttle up.
The reason why there's a difference in that number is because some rockets have more rocket on it than they do fuel tank. The shuttle is a good example. Right? The shuttle, you're trying to get this whole thing. You're trying to get wings. You're trying to get rudders. You're trying to get the payload bay. You're trying to get the crew, all the thrusters that you need to float around in space. You're trying to get all that up into space. So in rocket science, this is called a mass fraction. Okay? The mass fraction is how much fuel, how much of your rocket's mass is fuel and how much of your rocket's mass is rocket. Okay? Remember that. That's really important to understand for getting up there and getting up into space, okay? Hey, Taylor, what's up? How's it going? Good to see you again. Yeah, good to see you. All right, that's super important to get that right. The shuttle doesn't have a good mass fraction. Now, why? Why doesn't it have a good mass fraction? It's reusable. Reusable. Shuttle's designed to come back down and land. And it's also designed to bring the shuttle engines back. Right? Why would you? So that's why it takes a hit on mass fraction. And that's part of the reason why they needed 2 gigantic SRBs to get that whole thing to work, because yeah, you need enough power to move this brick of a spaceship up into space. What the concept that I'm illustrating here, guys, between like a fully expendable rocket and a reusable rocket is called a trade-off. Okay? Your mass fraction is going to suffer. Your rocket's not going to be as efficient if you have more rocket on your rocket, right? Right? Pretty straightforward to understand. You have more stuff to move, you're going to need more fuel. If you use the same amount of fuel to move more stuff, you're not going to go as far. Right? Think about it like if you're driving a car around, right? And you had a car that has 4 doors, right? If you took all the doors off, that same tank of gas would get you, your range would be increased, wouldn't it? But do you want to drive a car around with 4 doors? With no doors? Where there should be 4? No. You don't want to do that. Why? Your car is reusable, right? What if it rains? You're going to get wet, right? With no doors? It's a Jeep thing, man. You wouldn't understand. Hey, Mizzy, what's going on? So, there's a trade-off. The shuttle has a terrible mass fraction comparatively to like an expendable rocket. But you're trading that mass fraction for reuse. Okay? Yes, you have to move these wings up into space. They literally don't do anything, or actually don't do anything when you're up in space. Wings need air. Where the shuttle flies, it doesn't have air. But the trade-off is when you're coming back down, you can bring the shuttle back to a runway and land it and get your vehicle back. And then you get your upper stage engines technically back as well, right? So there's a trade-off there. That's an important thing to understand when you're trying to figure out why rocket staging is a good idea. Now, the Saturn V, for instance, the only part of the Saturn V that you get back is this cone piece up here, out of that whole rocket. Now, for reference here, a Saturn V is as tall as a 33-story building. It's a 33-foot wide core. at the widest down here. 10 meter core here, 6.6 meters here. So that's it's about 22 feet wide for the S4B. It's not a small rocket, it's gigantic. But that's why it stages. You have to stage because you have to discard the mass. You have to make sure your mass fraction is always on the way up. You really want it above 90 to 95%, right? So if this fuel tank drains, right, discard it, get rid of it. That's why rockets stages. That's why rockets have stages. You're dumping the dead weight. It's not weight, it's mass. I know that, all right? That's what decouplers do. Decouplers will separate you, right? And a stack separator will separate both sides, okay? Now, in here is payload bays, okay? This next thing, payload bays. Payload bays are for if you're trying to make a space shuttle in Kerbal, you have different payload bays. You could put things in them, and if you figure out, if you have a trade-off with your payload bay and give it some wings, you can bring it back. Right? You could build shuttles in KSP. You could build anything you want in KSP if you could prove that it works. You know? I know it's not the point, but if you take the doors off of your car, wouldn't the arrow cause it to use more gas? I'm probably wrong, but wondering. Depends. How fast are you going? Taylor, the example that I was giving is called a non-dimensional example. Think about it just in an ideal circumstances where arrow is not part of it. In real life, yeah, sure, dude. But, I mean, honestly, I would argue that it depends on how fast you're going. It really depends. If you're pedal to the floor and you're going 160 miles an hour down the road, yes, that would make a big difference. If you're going 15 miles an hour down the road, no, not really. Wouldn't make that much of a difference, dude. Yeah, once again, I will be giving examples that, like, in aerospace, like if you're doing basic math, like basic engineering, dude, and you're trying to understand formulas and stuff, it's called non-dimensional, meaning just think about it in an ideal scenario. Like, when aerospace students are first taught about like forces and how they work, you do a lot of non-dimensional calculations, meaning that, you know, if this is pushing on this, how much force does it make? You know, not taking into account gravity, not taking into account wind, or not taking into account drag or anything like that. So the example was non-dimensional, but yeah, I mean, in reality, yes, you have to deal with all of that. But I would, once again, argue it depends on how fast you're going. You have any idea how fast you were going? How fast you were going. I got you, man. All right, so what's the next thing? Wings. Wings and control surfaces. This is the arrow menu. Actually, it's just more than wings. We're going to need to make a stop here, so to speak. Now, this has all kinds of fun stuff. Remember I told you about the space shuttle. If we wanted to try and bring this rocket back, right, we could put wings on it and maybe have it glide back down or something, right? But that's added mass. You don't want that. Not necessarily. What are we trying to do here? Well, we're trying to get to space, right? That's the whole point. That's the point of this tutorial. Let's go to space. But I'm also giving a high-level overview while we do it. Now, the arrow menu has a lot of interesting things in it. We have helicopter blades if you have the breaking ground expansion. You have helicopter blades. Yes, you can make helicopters. There's also propellers. You can make prop planes in this game if you really want to. There's different types of intakes for your jet engines, right? Now, the intake only works if you have a jet engine. The intake does not work for a rocket engine. Well, put an asterisk next to that. It gets a little complicated, but you know, we have all different types of wing shapes and sizes in the stock game. You can And cool thing is that if you're making a plane, you can kind of put them in any way, shape, or form that you want. You can make cool stuff like Batman rocket, right? Like if you really want to. And I know what people are going to ask. Will it fly? I don't know. Try it. But that's not what we're trying to do. I would say try it. See if it does. Why don't they just use nuclear engines? What kind of nuclear engine? Can I build an X-Wing? Yes. The best kind. All right, so Axe, there are nuclear engines in the game. There is a nuclear engine, I should say. Right there. It's a nerve engine. It's based off of the Nerva. This is a real-life program called Nerva. This is a nuclear thermal rocket engine. What does a nuclear thermal rocket engine do in real life while we're on the subject? Okay, it's a nuclear reactor in here, and it flows hydrogen over the nuclear reactor to cool it, and that hydrogen gets superheated and they shoot it out of a nozzle. This is a nuclear thermal rocket engine. Why is this good? Well, nuclear thermal rocket engines offer pretty much double the efficiency of like a chemical combustion rocket engine. Rocket engines at the end of the day just combust things. It's no different than what a car does with gasoline and intake air. It really isn't. You need to atomize it to get it to explode and then shoot, a rocket engine just shoots the explosion out the bottom. A car engine uses it to push down a piston to create rotational force in a crankshaft. Same idea. Just a little semantic thing. Oh, that didn't take long. We got maybe 20 minutes into a tutorial. What do you have to say? Non-dimensionalizing is for things like Reynolds numbers or Mach number, meaningful quantities that don't have units. The word you were looking for was ideal. Do you have a YouTube channel? Of course I do, Deborah. I'm streaming on it right now. Hi, X-Wing. What's up? Now, Brian, I appreciate that. Yes, thank you for the correction. How does that help me explain what I'm trying to do better? All right, next thing here. Now, we have landing gear. It definitely doesn't, just wanted to share. Well, I appreciate it, man. Thank you. Always learning is good. All right, so landing legs here. This is pretty straightforward. You have landing legs. Some of them don't have wheels on the bottom. Some of them do. These are for landing things on celestial bodies. I don't know. Which one do you want? Pick one. Lunar landing legs. We have landing legs that are kind of like the LEM if you want. There's a couple of different sizes. Some of them you can deploy. Some of them retract. Some of them deploy. Actually, I think all of them do retract. All of the landing legs do. So you can use these to land on other planets, or you can use them to land Falcon 9 style if you want to. Now, you have those. You have different types of landing gear. Landing gear, if you're trying to make a plane, you have fixed landing gear like a Cessna here if you really want to. Right? So if you want to make your rocket have landing gear and land like an airplane, well, it's going to need some wings. But remember about that mass fraction thing. That's important to understand. Now, you have different sizes of landing gear all the way up to something that looks like a 777 landing gear. See? You got a bunch of different sizes. Now, keep in mind, some landing gear are steerable and some of them aren't. This landing gear can move. You can steer that landing gear. You can't steer the 3-bogeyed landing gear, the 2-bogeyed landing gear. Just remember that if you in the future. Now, also, you have rover wheels. You have different types of rover wheels. These rover wheels are electric, right? And you can use them for making rovers. If you want to make...
Oh, this is space.
Hello?
I'm in space.
Remo gifted 5 subs. Why did you... Why, Tanit? Why do you want me to look at a certain missile? Explain to me why you want me to see that. Nuclear engine. I don't want to get too into the weeds about different types of nuclear engines. Every time I talk about nuclear engines, I get well actually'd about it, dude. I'm really not looking to get into a discussion about different types of nukes or different systems. I just showed this. Remember, this is a Kerbal tutorial, dude. So if that engine that you're talking about on that missile that...
Oh, this is space. I'm in space.
That's there is not relevant to an engine in the game. I'm trying not to confuse people here. We can talk about it later, though, if you want. All right, Ren, thank you for the 5. I don't know why you're gifting 5 subs, but all right, whatever. All right, so where are we now? We're at thermal. So this is where the heat shields are. You have all different types of heat shields that you can use, very similar to Orion's if you want. These are what's called an ablator heat shield. Basically, it'll protect you, but you have a certain amount of ablator, and the more heat that gets introduced, the more the ablator goes away. And if the ablator goes to 0, you got a big problem. Yeah, you don't want the ablator to go to 0 while you're still re-entering. These heat shields burn off to shed heat. Just like that's what an ablative heat shield does. Like Orion's heat shield is an ablator heat shield. Now that's in contrast to like the space shuttle. The space shuttle has a silicate-based tile heat shield, right? And reinforced carbon on the nose. That's a reusable heat shield. The reusable heat shield, once again, we're getting into trade-offs now. Why make a reusable heat shield? You want a reusable heat shield if you're making a reusable vehicle. If you're making a reusable vehicle, right? You don't want an ablator. An ablator takes time to replace. Now the shuttle's tiles also ended up taking a long time to replace, but that's another story. So we don't have tiles in the game, right? So if you're making a space shuttle, like once again, Kerbal kind of abstracts the re-entry heating for gameplay purposes in the stock game. You can make it more difficult with mods if you really want to. But for the most part, like parts in KSP can take a good beating, but it is still cool to engineer the heat shield into your spacecraft. Now, we don't need a heat shield. I don't want to put a heat shield on the front of this thing. We don't need that. Going down here, right? Ooh, let me put the motor back on. After that, you have electrical. Electrical is where all your solar panels and batteries are. You could put batteries on your spaceship. You could put different types of solar panels that are deployable, right? And undeployable, right? Simultaneously, if you're cash strapped and you want to make single-use deployable solar panels, right? You can do that. See? There's single-use panels that you can only deploy once, and then there's redeployable panels. There's even cool circular panels. We like circular panels. Woo! Those are pretty neat. You can get all different types. There's the bigger circular solar panel. Oh no, those are the redeployable ones. Those are, you can retract them. Now, on top of that, we were talking about nuclear engines. There are other forms of power generation in this game. There's the RTG right here. This is the PBNUK, radioisotope thermoelectric generator. This thing is basically a ball of plutonium that generates electricity over time. The RTG basically never runs out of fuel. It always outputs 0.8 electrical unit a second. EJ, how could we use a cargo plane like an Antonov to launch a nuclear thermal powered rocket? Punger, I would prefer to just put a nuclear powered. So nuclear engines. Okay, let's once again. I don't want to get too far into the weeds here. The short answer here is that nuclear engines work better up in space. They work way more efficiently up. Well, not more efficiently. They work better up there. They don't generally make a lot of thrust, the nuclear thermal engine, right? But they're very efficient. So that's better for an upper stage. I'll get into that in a second when we actually get into building this thing out. Launching one off of a plane would be like, here, I want to make a train, so I'm going to put a rocket up in the air that delivers the train to the train tracks so the train can go faster. It's like, you want to make a rocket-powered train? No. I want to launch my train into the sky, have it start going fast, and then land it like an airplane on the rails to get it to go faster. That really doesn't make a lot of sense. I'm not saying it's not doable. I'm saying it doesn't make a lot of sense. But we can get into like design principles in a second. Let me just finish going through the list here. We're almost done. Wasn't there a way to launch a space shuttle from a 747? Harris, yes and no. Let's finish the rest of this stuff. So that's electrical. You got solar panels. You got nuclear powered stuff. You do have fuel cells here. Fuel cells will generate electrical power if the vehicle has liquid fuel and oxidizer on it. That's the only way the fuel cell will work. It needs liquid fuel and oxidizer to do it, but it'll take liquid fuel and oxidizer and make it into electricity. Okay? Yeah, once again, you have all different types of big old solar panels. See? Now, the next thing is communication. Communication, if you enable certain difficulty settings in KSP, dudes, you're going to need an antenna. Orion needs antennas. Orion has phased array antennas. Now, we don't have phased array antennas in stock KSP because this game is like 15 years old, or yeah, more or less 15 years old at this point, right? You just have regular antennas. Now, different antennas can go different distances. Some of them are deployable, like that one. You know, some of them are side deployable, etc., right? And yeah, it really depends on, like, with communications, you need line of sight, right? Like, if you go around the backside of the moon with communications on, you're going to get a communication blackout, just like you would in real life, if you enable this in your difficulty settings. Now, you can get around this by using relays. Relays are antennas that can bounce a signal. So if you have a satellite that's kind of near the moon, right, and you're transiting the backside of the moon like what Artemis 2 did, Kerbin can shoot a signal at your relay satellite, it can bounce off of it, and it can get to the craft so you never lose communication, right? How do I know where to put it? Well, gotta figure it out. Where's the place that's going to give you line of sight? Relays can be on the ground. They could be in a satellite. You have 3 different types of relays, and however many relays you put on your vehicle really depends on how far the signal can go. Now, there is a ground tracking station at Kerbal Spaceport. It's over there. And if you have communications on, you can upgrade your deep space network, so to speak, to talk further into space. That is a difficulty setting. If you're playing Kerbal on easy mode, you don't need to worry about that. Early J, it's just some project your group was talking about. The stage 1 nuclear thermal, stage 2 delta wing sweep, and launch from an AM-225. Okay. Something similar. Trying to see if I understood it right. Most likely there's a stage before the NTR. You tell me. I told you what nuclear engines do. Nuclear engines don't make a lot of thrust, but they're very efficient. What's the ceiling on an AN-225 if one existed? I know, it sucks. What's the flight ceiling on that? I have to say, it was awesome to watch the mission with you. Watch the landing and the mission with you. Yeah, VCLR, yeah, absolutely. Maddie, what's going on? Hey, I saw something really cool yesterday driving for work. Parts of a full-scale space shuttle attached to an elementary school. All right, that's cool. So let's say, all right, Punger, think about this for a second. Nuclear engines, very efficient, not a lot of thrust. What's the flight ceiling of a 225? The 225 probably can't go, I mean, I don't know. I'd have to go look. Let's just, let's go to the wiki as far as we can. So, AN 225, right? The Antonov 225, a big Russian cargo, or well, not, it was Soviet and then Ukrainian. Big cargo plane. It was used to move their space shuttle around, right? So, it has 6 turbofans, D-18s. Those are big. They're big. This was a big plane. Unfortunately, we like fighting. Everybody likes blowing things up, so that's what happened to it. Not cool. All right, let's go into specs. What's its flight ceiling? Or if it's an airplane, it's called the service ceiling. The service ceiling is 36,000 feet, okay? Or 11,000 meters. They'll build another one, guys, I'm pretty sure. There is spares. The Soviet Union was going to build a second one, so there's spares around. It's just I think that they have other things to worry about before they rebuild that cargo plane. Now, so Punger, think about this. Service ceiling, 11,000 meters. Now, what unit of measurement do you want? Do you want feet or do you want meters? I mean, you know what? I'll just do either one. It doesn't matter. All right, so 36,000 feet. To get to space, the kind of universally regarded altitude for space is about 355,000 feet. That's about 62 miles or about 100 kilometers. The AN-225, and this is what the reason why I kind of stopped and I'm talking to you about this right now, rather than keep going with KSP, is because this is an important thing to understand. Planes do not fly anywhere near space, nor do they fly anywhere fast enough. Okay? So, once again, to get above the kind of universally regarded line of where space starts and our atmosphere ends, it's called the Kármán line. It's 100 kilometers up, 62 miles, 355,000 feet that way. This thing gets nowhere near it. Okay? Not only that, but it goes nowhere near fast enough. Max cruising speed here is 460 knots, 530 miles an hour, about 850 kilometers an hour. That's pretty quick for a plane that big. But you want to know remember, how fast do you need to go to get into space? How fast do you need to be going to get into orbit? Do you guys remember? 17,500 miles an hour is what you need to get into space. And you need to be doing that above 100 kilometers or 62 miles that way. That's 27,500 kilometers an hour. So the plane is getting you less than 1/27th of the way there. In terms of speed. In terms of height, you're getting 1/10th of the way there. Now, what did I tell you about nuclear thermal rockets? They're very efficient, but they don't make a lot of thrust. Is a nuclear thermal rocket good to launch off of the back of an airplane? This technique is called stratolaunching, if anybody's curious of the exact term. Launching something from an airplane that flies into space. The fastest airplane, you guys want to see a kicker here? The fastest airplane, and you know, Tessa, you mentioned it. It's a good thing to bring up. The fastest airplane ever flown is the X-15. It's basically a cockpit with a rocket engine attached to the back. They launched it off of NASA, and the Air Force launched it off of a B-52. They stratolaunched it with a person inside of it. Neil Armstrong flew these for the Air Force before he joined NASA. The X-15 is the fastest plane we've ever made. Look at its speed. Here, let's go down to specs. Maximum speed, 45,020 miles an hour, 7,270 kilometers an hour, or 3,930 knots. Service ceiling, 354,000 feet, 108,000 meters. The X-15 can get up there, but nowhere near fast enough. It's suborbital at best. Remember, 17,500 miles an hour, 27,500 kph. You need to be booking to get into space. That's why rockets stage. And that's why we don't launch stuff off of an airplane. An airplane, even the fastest airplane in the world, by a long shot, is not getting you anywhere close to fast enough. This is why we fly rockets, and that's why rockets stage. This is slow. That's too slow. That's not fast enough. For real. You need to, this is what's cool. Like, this is why I think I like space so much, because you need to go fast to get into space. I like things that go fast. Cars, planes, trains, boats, rockets. Rockets go fast. Rockets are the fastest thing. Oh, hey, I've touched that airplane. Nice. The Air Force did their X-15 testing with two principal B-52 airframes. They're B-52As that they converted for high-altitude atmospheric testing. Because the B-52 can fly higher than an AN-225, believe it or not. B-52 with no payload can fly way higher. It can get way up there because it's designed to carry bombs. I'd prefer it do that, but hey, bombs are nice for something. So that's B-52 serial number 3. SN3 and SN8, or Balls 8. Balls 3 and Balls 8 were used for X-15 testing. That plane is still around. It's in Pima. It's at the Pima Air and Space Museum in Tucson. That plane still exists, which is kind of cool. I've seen that exact drop pylon, dude. I've touched it. Don't tell the Pima people that. Yeah. Do we count the X-43? We're talking about planes with people on board. Look at that thing. That thing goes... How fast did that X-15 get up to? Now, once again, I want to illustrate a point here. The X-15 can get high enough. It can get above the Kármán line, but it can't go nearly fast enough. Now, don't get me wrong. That's about a third of the way... Well, a little less than a third of the way there. That's pretty fast. Not fast enough, though. They studied the proposal of the AN-225 with the MAX spaceplane. Yeah, I know. You might be able to get away with a chemical rocket on top of an AN-225. Now, once again, guys, actually, if we look, that's not to say that there hasn't been... That's not to say that there hasn't been stuff launched into space from an airplane. This is the Spirit of Mojave. It's owned by a company called Stratolaunch. Before that, it was called Cosmic Girl, and it was operated by Virgin Orbital. So, there it is when it was operated by Virgin Orbital, and it used the 747's fifth pylon to mount a two-stage rocket and launch that sucker into space. Unfortunately, Virgin Orbit folded, and they sold the plane to Stratolaunch. It's been done. It can be done, all right? But, Punger, not with a nuclear engine. A nuclear engine isn't going to give you the kick that you need. Nuclear engines are very efficient, and they provide a little bit of thrust for an extremely long period of time. About double the efficiency, or double the miles per gallon of their chemical counterparts. Now that one, that's a combustion rocket. So it's a two-stage launcher. It's called Launcher 1. I believe they were using hydrolox. Long story short, not enough thrust to weight, falls like a rock. That thing works. It worked once. And you can do it for what it's worth. That's not the only time we've done that. There's actually another one coming up soon. Another Stratolaunch thing. There's another Stratolauncher around called Stargazer. Stargazer is a Lockheed TriStar. It's the only Lockheed TriStar in existence that's still airworthy. It's a TriStar that can carry a missile underneath its belly. That missile is called Pegasus. And Pegasus can get into space. So, like I said, you can Stratolaunch. It's been done. But you're not going to do it with a nuclear engine. Pegasus is all solids. Is there an actual video of it? Yeah, this is June 1st for the Pegasus launch. Now, unfortunately, if you think that's a really cool idea, or if you like TriStars, that June 1st is the last launch for it. This is in 2026. Yeah, last launch. Pegasus has been around for a while. Now, hey, Rob, you enjoyed the Artemis 2 coverage. Thanks. Absolutely. I think that's a shame. I love TriStars. I think TriStars are better than an MD-11. I think MD-11s and DC-10s were gigantic steaming piles of McDonnell Douglas. TriStars are better. Sorry, Lockheed don't miss. You can't argue that. Look at what they did with Orion. Lockheed don't miss. They got it right. So yeah, there you go. Stargazer. It launches the Pegasus. So like once again, this can be done, but here's the thing. You can only really get away with what's called a small sat launcher. The reason why is because even the AN-225, guys. All right, so let's do another little bit of a calculation understanding thing, all right? Let's go back to the Dream, all right? So AN-225. What's that? That's the biggest plane that can move the most amount of cargo around. What's its max cargo capacity? Okay, the max takeoff weight, or MTOW, is 640,000 kilos. So that's 640 tons. All right? That's the biggest plane in the world. About 1.4 million pounds. Okay. Now, let's look at a S4B. This is just the Saturn V's third stage. So that's the S4B. That's the third stage for a Saturn V. Look. Gross mass. So that's the entire rocket with the fuel, not even with payload. 271,000 pounds. 123,000 kilos. Could you put an S4B on top? Yeah. But does the S4B have enough fuel to get you up into space? Maybe. Depends on what you put on top of it. If you put the LEM on top of it, right? You put the lander and the Apollo CSM on top of it, maybe you'll have enough. Maybe it'll get that up into space. It might. It actually might. It's close. If I'm looking at this right. I bet you if you just launched an S4B on top of an AN-225, provided you could figure out how to do that, I bet you it could make it. But, okay. So, what if you do? What if it makes it? Great. You have an empty S4B sitting in low Earth orbit. Lovely. If you put anything on top of that, any useful payload on top of that, you're not... I'll bet you it could move maybe a ton. Maybe 1,000 kilos, so that's 2,200 pounds at best, maybe. Most of your Delta V, and I'll get more into Delta V, most of your Delta V would be used getting up there and then going fast. The plane is not going to give you the dividends that you think. And this is with the heaviest, the biggest plane around. And actually, you know, I'll be honest with you, 123,000 kilos. Damn, dude. With the 225, you might be able to get away with this. But once again, at this point, you've just made a low Earth orbit access vehicle. You made something analogous to like maybe an Electron rocket. You made a small sat launcher. Yeah, that I'm using MTOW. If we want, let's see, cargo hold. Right? Yeah. Where's our payload capacity? Oh, up here. 253.82 tons. Nope. Nope. Can't lift it. Too heavy. I was using max takeoff. Yeah, see, gross mass right there? That's the entire stage full of fuel. Full of fuel and oxidizer. Well, 123. Hold on. I mean, you could get away with it. You could do it. But here's the thing. Like, okay, the point that I'm trying to illustrate, like, I actually didn't think it would be able to lift it, to be honest with you. The point that I'm trying to illustrate here is like, okay, so you did this, right? And now that probably, if we did the calculations, that would barely, and I mean barely, make it into space. Like, barely make it into space. You wouldn't be able to put anything useful on top of this S4B. It would use most of its fuel just getting itself up into space. Now, comparatively, you put that on top of an S1, right, with an S4B on top of it. Now, with this configuration, this thing is way simpler than an AN225. It's going to make you go a lot further and a lot faster. With that thing, with the first stage attached to it, right, now this thing has 20 tons of payload capacity instead of 1. And that's the point I'm trying to illustrate. Can you put this on there? Yeah. Yeah, you could probably mount one up there. I mean, good luck when the engine fires. I'm not sure what you're going to do because you have a rocket engine igniting next to your airplane. Because it wouldn't be able to undersling it. You'd have to mount it up here where they wanted to mount Buran. Could it be done? Sure. Yeah. I mean, you might be able to get away with it. You need a pretty sophisticated launcher there. But like I said, what's that going to do? It's going to make it so it gets you an empty S4B into space, and that's about it. Yeah. But I mean, the numbers say it could be done, but I don't think something tells me about an S4B, if a rocket engine ignited when this thing was attached, you'd have a real bad day. Yeah, you would have a very bad day. The back of the plane would probably melt. And once again, like, that's the heaviest plane using a stage that I thought of off the top of my head. Like, it's actually enough to carry it full, which is pretty insane. That's a testament to that thing's design. But even then, this would probably end up getting you maybe about a smart car's worth of payload into space, maybe, if you're lucky. Comparatively to if you put an S4B on top of a Saturn 1B, that could get you like probably 20 smart cars worth of payload into space. See the difference? That's why stratolaunching is cool. Don't get me wrong. It's really neat. But it can only get you so far. You're only really limited by how high and how far the plane can fly. Parabolic flight. Yeah, once again, Stillfire, you guys are missing the point. This isn't about proving Strimmerman wrong to say that it can or can't be done. All right? It can be done. Yeah, with the numbers. I mean, if you could figure out all the different ways to make that all work, but at the end of the day, you made something that can move one smart car into space. If you just put it on top of a stage right there, that is arguably way less complicated than an AN225, then you can get 20 smart cars worth into payload into space in one shot. It's not that it can't be done. It's that it doesn't really make any sense. What are you trying to do? This is much easier. This gets you way more payload into space. And it uses the same upper stage. Right? And once again, that's the trade-offs that you have to think about when you're playing Kerbal. If you want to design rockets in real life, you want to understand how rockets work, that's the trade-offs you play with. Guys, I don't mean to be cynical, all right? You're not going to win against thermodynamics and against physics. You're not going to win. There's this thing called entropy, and the laws of thermodynamics and the laws of physics are kind of subject to it. meaning whatever you put in, you're never going to get 100% of that back. It's just kind of how that works. That's how our universe works with our current understanding. Like there's different ways to get to your final destination, right? But at the end of the day, like say you're driving from point A to point B, there's 1,000 different ways to get there, right? Some ways might be faster, some ways might be slower, depending on traffic, depending on road conditions. Arguably, the fastest point is a straight line between 2 points, right? But are you going to drive your car in a straight line between 2 points? Only if there was a road there, right? Now, say you have an off-road vehicle, right? And you want to drive through, you're going to drive through somebody's house to get to your destination? There's 1,000 different ways to get between 2 points here, all right? But, it really depends on what you're trying to do. You know, you want to get there just in a regular car using a road, right? That might be easier, but you could make an off-road vehicle and go off-road between 2 points, right? With engineering, there's 1,000 ways to get there, to get to your destination. But you're always going to have to use something to get there, and you're never going to get it back. So like if you're trying to get from point A to point B with your car, you're going to fill it up with gasoline or you're going to charge it with electricity, right? Right? You're not getting that electricity back. You're definitely not getting the gasoline back. You're going to use it to move something somewhere, right? That's what I mean. That's an important thing to understand with the laws of thermodynamics. You're never going to win. You can't have your cake and eat it too. That's why trade-offs are a thing in engineering. You're never going to win. Physics in spaceflight in general is just like playing a game of Tetris. You don't really win, you just kind of get better at it over time. You absolutely can lose, but ideally you just kind of get better over time. But you're never winning. Yeah, Tessa, let's just make things more complicated than we already are. Remember when I said like a half hour ago that I didn't want to get too far into the weeds? Yeah, you're making that worse. Please stop. Before I slap you. I know it can move too. I get it. I saw the numbers. Thank you. How does that make this conversation? What is that? What conversation? What does that add to this conversation? Yeah, let's just teach people that thermodynamics are a construct, are a social construct, and that they're not beholden to it. That will certainly make better engineers, won't it? Yeah, no, great addition to the conversation. Yeah, keep up the good work. Anyway, last couple of things here. So, the science category. In Kerbal, the science equipment here is used for career mode or science mode. Career mode has science mode in it, and science mode is science mode without career. There's a couple of different game types you can play in KSP. These different pieces of scientific equipment are there to gather what's called science knowledge. And in career mode or in science mode, you use that knowledge to unlock better parts. For instance, in Kerbal, there's a shuttle engine. You have a shuttle engine. There it is, right there. It works like the shuttle engine. It works great. I use them on my space shuttle, right? It's the KS-25. That's a more late game rocket engine, right? Because the space shuttle engine, you're not gonna say, I'm gonna start a rocket company and build a space shuttle engine as my first rocket. That's not how SpaceX got started. SpaceX got started making something way simpler. They didn't start with a Raptor, right? NASA didn't start with a shuttle engine. They teched to it. So in Kerbal, you use science to unlock better fuel tanks, better engines. You could use it to unlock better antennas, better landing gear, etc., etc. You have something like a thermometer to go observe stuff, right? You have what's called mystery goo. If you deploy it, you expose the mystery goo to different environments, right? And it'll get you a scientific return here. Give me 1 sec. That's what those science parts are used for. You don't necessarily need them if you're just playing sandbox. Some of the science equipment themselves you have to unlock over time. Now, down here, you have cargo. In Kerbal, you have surface experiments packages. The surface experiments packages you can load into cargo containers, and then say if we landed this on the moon, our Kerbals can go up to this, pick this thing up, and drop it down onto the surface. That's part of the Kerbal inventory system that the developers added to the game. There's anything from just like a light to an anchor point that you can attach something to the ground with. In the inventory, there's parachutes. Don't think I need to say why you need those, or don't. There's repair kits. The repair kits can be deployed by Kerbals to repair rover wheels. Sometimes your tires pop with rover wheels. There's EVA fuel cylinders. Kerbals do have jetpacks that they can use up in space if you give them a jetpack, that is. There's the jetpack right there, and you can use the EVA cylinders to refuel them. There's EVA surface experiments kits. There's communication kits to make your ground experiments work. You could put a seismometer down and then crash stuff into the surface of a planet to get science points to see if the seismometer goes off. Yeah, surface experiments packages. These are based, this whole bit of gameplay is based off of a thing in real life called ALSEP. ALSEP is the Apollo Lunar Surface Experiments packages. See, when they went to the moon, when NASA went to the moon from 69 to 72, they dropped down a bunch of things down onto the surface to test a bunch of things. There's the seismometer from Apollo 16. They also brought nuclear stuff down too. You can actually see it. You could see the RTG right there. They did that to test to see if they could put a little RTG on the moon, which is basically just it's not a nuclear reactor. It's just using decay heat from nuclear materials to make electricity. So it trickle charges stuff for centuries, literally centuries. Those things are probably, if I had to guess, they're probably still generating power. The ones that we placed up there 53 years ago, they're probably still generating power. Either that or they melted. Either one or the other. Yep. They brought up RTGs on Apollo, dude. Yep. Seismometers. One of the things that they brought up were the laser reflectors. Yeah, Snap 27, dude. The laser reflectors. Passive lunar... no, that's the seismic experiments. There's the magnetometer. Magnetometers are used to... well, measure magnetic fields. That's... Where the heck is it? Yeah, see? Radioisotope thermoelectric generator. They're probably, like I said, if they're intact, they're probably still generating power. They're using what's called a thermocouple. Thermocouple takes heat and makes it electricity. It's very, very high level overview. This is the one. So, these things here, the laser ranging retroreflectors, all right, from the Apollo program, it's a passive experiment. You can still use these today. This is one of the biggest arguments for like we went to the moon, because what the laser retroreflectors do is if you have a high-powered laser, you can bounce it off the surface of the moon with that thing. You wouldn't be able to bounce it off of lunar dirt. You'd need to bounce it off of a retroreflector. It's one of the ways how the laser ranging experiments, guys, were one of the ways we figured out that the moon is slowly drifting away from Earth, because you ping it with the laser and you can figure out how far it is away. The moon is moving away from the Earth at about 1 inch per year. Don't worry, it's not leaving the night sky for millennia. But yeah, it does move away about this much every year. But yeah, that's one of the, you wouldn't be able to do this unless somebody put something up there, because you can't bounce a laser off of the dirt. You can bounce it off of that though. And that's an experiment that I'm not sure. Not everybody can do it, but yeah, like it's one of the easiest ways to be able to figure out that we put stuff up there. And we sent people up there because the retroreflector arrays wouldn't be there unless somebody put them there. Please come back, Moon. We love you. Well, that's not entirely true, Mayor. The reason why... I know you're making a joke, but the reason why the moon is moving away at 1 inch per year is because Earth's pushing it away. We're pushing it away. We don't love the moon. We're pushing it away. Is the mystery goo the KSP version of aerogel? No. It's just mystery goo. Nobody knows what mystery goo is. How is it actually moving away? That's a good question. The moon is moving away at about 1 inch per year. About, for the metric people, that's about 25 millimeter a year. Because of a phenomenon in orbital mechanics called precession. Okay, the right way to say that is that the right way to say this, and you guys have heard me say this explanation before if you watch the Artemis 2 coverage, is the Earth is not like a perfect sphere, right? It's not like perfectly round. It's kind of like if you took like a soccer ball and kind of pushed on it on both sides, kind of bulges at the center a little bit. The reason why is because the Earth isn't solid. It's solid to us, like, you know, we call it terra firma, right? It's solid to us because we're on the cool crust of a gigantic molten nickel iron sloshing jello mold of fun. Right? You know, we have the kind of core of the Earth is more liquid. It's liquidy. And that gives us plate tectonics, etc., etc. But because the Earth is this big jello moldy thing, right? It's kind of weeble wobbling around. And that puts the Earth's center of gravity, not necessarily, like if we have the Earth here, it doesn't put the center of gravity at the exact geometric center of the Earth. It's not perfect, right? And because of that, the Earth kind of weeble wobbles around. That weeble wobbling force creates a more or less non-uniform gravitational pull. And because of this, it pushes the moon away a little bit every year. Yep. And because the moon is moving away, it's slowing down Earth's rotation. Yep. Equal and opposite reactions. That's right. Physics. Yeah, weird, huh? Now, don't get me wrong. This is not like some crazy doomsday thing like, oh my gosh, we're doomed. No, it's just, don't worry. That ain't gonna be our problem. That ain't gonna be our kids' problem. That ain't gonna be our kids' problem. Don't worry about it. That's just the universe doing it, or a solar system doing its thing. Like, that's not, and even then, like, yeah, that's not, that the heat, I'm pretty sure, now somebody's gonna have to quote me on this one. I'm pretty sure our sun will explode before the moon leaves Earth's gravity. Yeah, I'm pretty sure our solar system will explode before that happens. So, yeah, don't worry about it. It ain't no problem. Hopefully we're, you know, in another star system before that happens, you know? All right, so that's the surface experiment stuff here. The last thing here is utility. Now, in Kerbal, you can go mine resources off of other planets. That's what those ore tanks were for in the fuel tank category. You're gonna need a drill, right? You need a drill, you need to generate power for the drill, you gotta land something on the surface, and then you need the convertitron. This thing right here can take ore and it can convert it into fuel. You can use that to make gas stations on other planets, so to speak. How do you do it? I don't know. Get up there and figure it out. Now, utility also has stuff like that. Passenger quarters. Passenger quarters also has a cargo hold in it for your rubber ducks and hockey pucks. Right? There's different sizes. You can have Kerbals, you can have cargo in here. There's different types of fuselages, etc., right? There's also lights. Remember, where you land, sometimes it might be at night. So there are lights in the game, and you can use the lights to, you know, illuminate your dark landing site. There are also fireworks launchers that they added to the game, which is kind of cool, but they're firework launchers. I don't think I need to explain what that does. There's also flags. If you've seen that some of my vehicles have text, like textures and letters and stuff on them, it's because when they added flags to the game, they made it so you can upload your own flag. You can upload your own custom flag, right? I have a flag pack that in the Twitch chat, if you type in !flags, you can get the letters. I have English letters, and the flag pack also has Cyrillic in it too, because there's Russian rocket parts in the game. I'm gonna paste that link over in the YouTube chat as well. If you guys want the flag pack, it's there. I have the Russian letters, and then I have the color swatches, checkerboards, and then English letters. But yeah, you can make your own flag. You can make your own flags. You just need to make it in the right shape, and then you can put it in the game files and go. Yeah, Kerbals can also, if they land on another celestial body, you can plant a flag. But yeah, that's kind of an overview of all the different things that you can do. Now, we launched our tutorial craft here. It's not very aerodynamic. So, let's fix that. Let's go into our aero category where we have nose cones, and let's go find a nose cone. How about that one? Okay, attach our nose cone, and then let's just, yeah, we can leave it like that. That's fine. Save this. Let's go over to the launch pad. We'll switch editors into the VAB here, and let's launch this. Let's see if this works. So, let's try to get up into space, shall we? Got an overview of how every single part works, more or less. Let's get up into space. How are we going to do this? Okay. Yeah, Sesh, that'd be funny. All right. So we activated our engine. This right here, if you've seen me toggle this on or off a couple of times here, that is your stability assist. That will basically, depending on your probe core, it'll hold it in one direction. This is heading lock, meaning that when this is enabled, the rocket's going to try to keep pointing in the direction that, well, in this case, straight up, until I do something with it. If you see me maneuver around, you probably see that it's recycling. See that? That's it recentering. So, let's get up into space, shall we? Ready? Here we go. I'm just going to throttle back here. I'm worried about that nose cone. The nose cone might be good enough. I don't know. Let's see. The reason why you want to throttle back is because if you try to accelerate here when you're down near the surface, well, that's where the air is the most dense, like me. That's where the air is the most dense. There's a lot more air down near the surface than there is up in the air. Up at the top here, you have your altitude, you have your vertical speed, which is how fast you're going up or down, and then you have your atmospheric density. Uh-oh. Oh, no. We spun out again. Even with the nose cone up at the front. Crap. That's why you don't want to go too fast, and that's why a lot of rockets throttle down on the way up, because if you go too fast, the rocket's trying to move too much air out of the way, and you get what's called the dynamic pressure on the front of the vehicle. And that dynamic pressure will affect how the vehicle flies. The reason why is that the air will get hung up here. It'll get compressed because gases can compress, right? You can compress gases in like a scuba tank or something, right? So if your dynamic pressure up at the top gets too much, it'll want to spin the rocket out of control, right? That's what's called the center of pressure. Higher dynamic pressure will shift a center of pressure on a vehicle, and they'll make it go too far up. If you go too far up, you're gonna have a bad time. It'll spin your rocket out. Your rocket will start to fishtail because, once again, so much drag up at the front of the vehicle. Now, we just keep the throttle nice and low here. Check this out. Maybe this engine is too much for this design. But then again, you got to remember what we're trying to do here. What are we doing? Well, we're trying to get up into space. All right. Throttle up. I think we're high enough out of the atmosphere here. Uh-oh. I ran out of fuel. So we went up, just like the X-15 did, right? But we have the altitude. We're going to get up into space, but we ain't going fast enough. Not even close. This did get us up there, which is nice. This right here is what's called a suborbital trajectory. Suborbital trajectory is when you're coming back down. The planet that you're trying to orbit around is, you don't have enough speed to fall around it, so it's going to pull you back. Also, I'm spinning out of control, but no, whatever. Let me just check something here. Yeah, it's an intermediate range ballistic missile. Congratulations, you did an Alan Shepard. Yeah, Alan Shepard on in his Mercury Redstone flight, the first American to get into space, flew something like that. So the reason why I did this is because I knew this was going to happen. I knew the rocket was going to flip out of control, and I knew we didn't have enough fuel to accelerate to the speed that we needed to get into space. Remember, spaceflight is all about speed. It's about how fast you can go. Right? You need to be going to a certain speed to be able to orbit around the planet. Okay? Now, once again, and Brian, if you're still here, I'll use that's the ideal, okay? There are other things at play here. Let's just say to get into a circular orbit, let's get into orbit at 100 kilometers, more or less, circular. In order to do that, we need to accelerate to a certain speed. For Earth, Earth is a little bit bigger than Kerbin. Earth is probably the size of the moon's orbit in KSP. That's about the size of Earth in real life. Kerbal's about 1/10 the size, but it has the same amount of gravity, which means that Kerbal most likely has a tungsten core or something. To be 1/10 the size of Earth but have the same gravity, it needs to be like neutron star dense, right? But that's another story. Now, in real life, like I said, to accelerate to orbit, you need to go 17,500 miles an hour, or about 27,500 kilometers an hour, somewhere around there. It really depends. It depends on what type of orbit you're going to. But if we want to be perfectly circular, that's more or less where you need to go. In Kerbal, now Kerbal is in meters a second, right? It's in metric. Whatever, that's fine. The magic number to go fast enough in Kerbal is 2,300 meters a second, right? 2,300 meters a second is how fast we need to go. Here, we can kind of time warp here. I'm trying to see if I can get rid of the jello water. High fraction of lead and uranium or something. Yeah, well, I mean, that would uranium explain why Kerbals are green. Carbon is so dense its soil would sink into tungsten red. Oh my goodness. I thought it was in Kerbal constructs, but yeah, whatever. Doesn't matter. Point is this is gonna splash down in the water somewhere. Let's save some time here. All right, so tutorial craft 1 isn't getting us where we want to go. Now, I said, let's go back into the hangar. I like using the spaceplane hangar, guys, for editing. You can use the VAB if you want, but I like using this because if you click and hold middle mouse button, you can move the camera around like this, and you're not just doing that. You can only do this in the VAB. I always like designing in the hangar. So, yeah, it doesn't really matter. Use whatever one you like. Yeah, that's what max Q is, Missy. All right, so now let's think about this for a second. I told you it's about speed, right? That's how fast you need to go to get up into space. In Kerbal, we need 2,300 meters a second to get into orbit, right? 2,300 meters a second is the speed that you need to be at to orbit around Kerbin. Now, how do I want to say this? Okay, when you think about rockets, all right, so the important thing to understand with rockets is that I'm explaining this in a very specific way about accelerating to certain speeds. The reason why is because rockets, or a spacecraft or a rocket's range is not measured in distance, okay? When we think range, like let's say a car, for instance, what's the range of a car measured in? It's measured in, well, a unit of distance. So miles, kilometers, nautical miles for ships, I guess, and planes, right? It's measured in a distance. A car will get 300 miles to a tank of gas, or 400 miles to a tank of gas, or 400-mile range on an electric charge, all right? That's not how you measure spacecraft. Because it's all about speed, being able to get to orbits, right? You need enough speed to get into orbit. You need enough speed to be able to go fast enough to be able to get out to the moon. You need enough speed to be able to go from the Earth to Mars, right? To accelerate to, so you can get to that wherever your destination is, right? Because of this, spacecraft range is measured in acceleration. More change in velocity, right? I know that sounds weird, right? But if you're newer to spaceflight, you want to understand how it works. It's important to understand this. It's not about how far you can go. It's about how fast you can go. That's very important. Now, the formula for this is right there. It's the top one. This one right here. Now I know what people are doing. I just clicked this open and some people are going, the math, no, don't worry. It's not hard. It's not a big deal. Trust me. Now, once again, how you determine how far a spacecraft can go is measured in your change in velocity, okay? Or delta V for short, okay? Delta is a Greek letter, and in mathematics, it means change, okay? Delta is just a triangle. It's just a triangle, right? That's the Greek character for it. So delta V would be change in velocity. Delta T would be change in temperature. Delta P would be change in pressure, right? NASA, during the Artemis 1 coverage, I don't know why, but anytime they said something changed, they said, okay, a few deltas here for you, Reed. We need 3 deltas on your x-axis, 3 meters a second, whatever, right? That it's in mathematics. I don't know why they just say delta instead of change. That's very strange. But in mathematics, delta is the Greek symbol. It's a Greek symbol and it's used for change. Okay. So we need to be able to change our velocity from 0 on the surface to 2,300 meters a second, right? Right? So Kerbal is pretty handy. It does have a built-in delta V calculator down there. If you look, see it? Now, what does this say? Oh, look, this rocket, the delta V down there says 2,558. Isn't that enough? Yes and no. On paper, it's enough. But remember, I was talking about, well, non-dimensional is, yeah, or ideal, right? In an ideal circumstance, right? That's enough delta V to get up into space. What other factors would influence how much delta V you would have going up into space? This rocket clearly has enough delta V. It has enough to be able to get up into space. Right? Why didn't it get to space then? Anybody? Don't answer if you know the answer to this question. If somebody's following along with this tutorial, I want them to guess. Why? That rocket has enough delta V to get into orbit around Kerbin, so why didn't it? It didn't believe in itself. Gravity. Well, we didn't accelerate to the right speed, so gravity pulled us back in. Some of you got it. Atmosphere. The air is in the way. I gave you the answer on the way up. Remember, I said we're going to throttle the engine down, right? Because the atmosphere is in the way. We want to ideally go faster when we're up there, where there's no atmosphere. No atmosphere in the way is less things for your rocket to run into. That's less impedance on the vehicle to go fast. That's the other reason why first and second stages on rockets exist. Your first stage is designed to get you up there. Your second stage is designed to go fast. Right? We have enough delta V on paper to get up into space, but we couldn't because the drag slowed us down. Right? Even with our nose cone, still wasn't good enough. That's right. If you said we're thinking atmosphere, yeah, the atmosphere gets in the way. That does influence your delta V a little bit, your delta V equation. Now, let me show you something. In Kerbal, there's this thing called the delta V map. The delta V map is styled to look like a subway map. Let me show you. Here it is. This will tell you the delta V that you need to get anywhere, any planet in Kerbal, by just using the transfers. Now we're starting, we don't need to, we can go all the way up here. There's all this stuff, etc., etc. There's Duna, which is the Mars equivalent. Ike is kind of like Phobos. Eve is kind of like Venus. Gilly is something. Moho is kind of like Mercury. Kerbal is the sun. Right? Elu is kind of like Pluto. Jewel is kind of like Jupiter. Minmus is a captured comet around Kerbin. Moon is like our moon. Kerbin is like Earth, right? So let's take a look at this map. It says we need 3,400 meters a second, 3.4 kilometers a second delta V to get into space. There's the Kraken, by the way. We need 3,400. The reason why we need 3,400 is because the rocket has to push against the atmosphere. Drag is going to slow us down. So you need more delta V than you think. Why is Raptor Side chat going on today? Isn't it Wednesday? Whatever, it doesn't matter. So you need more delta V. Hey, Chief, what's going on? So you need more delta V than you think you need here because Kerbin's atmosphere gets in the way. Same is the case for Earth. Now, here's the numbers relative to Earth. On Earth, you need to be going about 7.6 kilometers a second. 7.6 kilometers a second, so 7,600 meters a second. That's that 17,500 or 27,500 kilometers an hour, 17,500 miles an hour that I was telling you guys about, right? That's how fast you need to go. But 7,600 is orbital velocity in meters a second, right? Times that number by 3.3 if you want the feet per second. On Earth, 7,600 meters a second delta V is not going to get you into space. 9,000 meters a second is going to get you into space. That's what you need to overcome the atmosphere and accelerate enough to get into space, right? So, let's do that, right? Let's do this. Take a look. Song, track, upside, hold on. I'll link up my playlist for you here in a second. There's the playlist that I'm using right now. Song is in there somewhere. I believe it's called Stellar Pulse. So, 2558. We need more fuel, right? Okay. Let's give this thing more fuel. How about we double it? What does that do? That's 3393. That's close. Should be good. $33.93 should get us close. I think if we fly a nice trajectory, we should be good. So let's take tutorial 1 craft, right? Let's put it back in the hangar. Now, just on a quick side note, cool thing that you can do is you can change the color of the tanks. If you really want to. With mods, you can make them look like whatever, but... Right, let's, the other thing that you can do is have some fun with the flags here. This is our tutorial rocket, so today, Junior? What once there what was he can't even read. So that's cool. We have tutorial 1, and then maybe we put our, you know, you could put your logo on there. Like I have my worm logo. There we go. All right, cool. The flags are not anything that's like, you don't need them. They're just kind of there to be cool. The spacing on the letters is all wrong, but oh well, send it. Now, another thing that you could do is utilize something called gizmos in KSP. Gizmos will allow you to place parts around. So if you were looking at this thing and saying, why the heck is there a gap where the probe core should be? Why isn't the probe core in the nose cone? Well, there you go. Kerbal doesn't understand the difference, for what it's worth. The aerodynamic simulation in Kerbal doesn't know the difference between that nose cone sitting on top of the probe core or moving it down. It's going to fly the exact same way. Kerbal has aerodynamics that are good enough to get the point across to teach people that want to understand how very basic aerodynamics work, but it's not like Flight Simulator or something. How big is this cone? How big is the cone? So a Kerbal, if you look at, see the little green men walking around, a Kerbal is about the size of one of these fuel tanks, right? That's give or take about like a cylinder that a Kerbal could fit inside of, so to speak. Kerbals are about 1 meter tall. They're little green men. So that nose cone is, if I was standing up, that nose cone would probably be about here from the ground. Not big. Herbals are smaller, so all the parts in KSP are a little bit smaller. The rocket engines in stock KSP are also kind of not really as powerful as their real-life counterparts. If you're a Titan missile fan like I am, you'll notice that that's an LR-87. But it's not. It's an LVT X-87 Bobcat engine. It's not exactly like its real-life counterpart. It's just an analog. All right, so we extended our fuel tanks. We have 3392. This should get us close. This should get us close into orbit. If we can fly it right. Let's see if aerodynamics are going to play havoc with this thing again. All right. Ready? Activate the engine. Turn on our heading lock. 3, 2, 1. Now note the rocket didn't get off the pad as quickly that time. The reason why it didn't get off the pad as quickly is because we're almost twice as heavy now, or twice as much mass, because we added more, we doubled our fuel tank capacity. All right, remember, we got to go up, and then we got to go fast. All right, so the first thing we do is go up. When we think we're high enough to be able to turn and burn, right? We fly on more or less a parabolic arc, which means as you go higher, the more parallel, or the further you are in your ascent, the more parallel you are to the ground, right? So we're going to start by going up, right? And then as we go higher, we'll tilt the vehicle over. So they're about the size of a minion. Yes. See, we're higher up here. Oh, uh-oh. Aero took it again. My dynamic pressure was too much on the top of the vehicle. All right, that's not great. So Aero got us again. That happens. What's the solution? How do you display the Aero UI? You got to go into the debug menu. Staging? No. SRBs? Drain the bottom fuel tank first. Well, if we drain the bottom fuel tank first, our center of gravity is going to be down here. You generally want your center of mass, or center of gravity, to be closer to the nose cone of a vehicle for more stability. Don't move that fast. Throttle the engine down? I can do that. Sure, let's do that. Remember, always try to find a fix that doesn't, like, require modifying the vehicle unless you absolutely need to, right? Let's try that. Ready? 3, 2, 1, let's jam. All right, cool. Let's slow down a little bit. You got that backwards. No, I don't. You do. All right, so we're going up. Oh, I see what that person was saying. Drain the bottom fuel tank first, not top to bottom. Drain bottom to top. That'd actually work, sure. Yeah, what I said about center of gravity is not wrong. But if you would drain that tank first, sure, we could drain bottom to top. That could work. But this is working pretty well right now, wouldn't you say? We didn't need to change anything about our plumbing. Hey, Cola, what's going on? 30-month resub. All right. No, it's trying. It's trying to... Oh, boy. Trying to turn it without some bad stuff happening here. Okay, I think we're high enough above the atmosphere where we could throttle the engine up. So let's do that. Let's kick it. So over time, you generally go more parallel to the ground here. Now, we're going to map view. Okay, so we're definitely going high enough here. Now, are we going to have enough? Let's throttle back a little bit, maybe. Actually, just keep going. Are we going to have enough to make it? No. Close. But no. We're still suborbital. We're close to being orbital, though. That was close. So tutorial 1 didn't make it. But, remember, I'm doing this to illustrate, like, look, you can get into space. Space is just 100 kilometers that way. It's about 62 miles that way. That's not that far. That's the easy part. The hard part is going fast. Now look, we're not going fast enough. See that? Not fast enough. All right, so throttle modulation, more throttle modulation, throttling up and down at certain times could definitely help us. But what the heck's wrong with this? The reason why we didn't really make it is because I throttled down, and what that did is we incurred what's called a gravity loss there. When I was pushing up, we were still going up, but we had to throttle the engine down so the aerodynamics wouldn't screw us up, right? Because we had to do that, that's more time that gravity is pushing down on the vehicle. That's called a grav loss, okay? Now, we want to be able to go faster in the lower parts of the atmosphere. Not too fast, right? But we want to be able to go faster. So, some of you already said it, so I'm just going to do it. Fins. Put some fins on the bottom of this thing. No, that's too big. Let's put fins down here. Now, how many fins do we want? Why not too fast? Heat? Well, if we were going too fast, drag built up on the front of, the front of the vehicle created too much drag. Pressure built up on the front of the vehicle, and the vehicle flips over. 3. 3 is the minimal amount that we need to be stable on 3 axes. Meaning, yaw, pitch, and roll. This will keep us stable on 3. So, I don't know. Where do you guys want them? Here, let's take a look. In Kerbal, you can bring up your center of gravity here, and you can also bring up your center of thrust. So that's where the rocket engine's effective force is being projected, and that's the direction that it's going. All right? You can also bring up center of lift if you're making an airplane. Our center of lift is over there. The reason why our center of lift is over there is because that's where the wings are. Wings are going to generate lift. Right? So let's, let's attach them here. Keep it nice and firm, right? Why do fins make it stable? Because they lower our center of pressure. All right? This is an important thing to understand with dynamic pressure and whatnot. All right? So, we're going fast. The nose cone up here needs to move air out of the way. That's why it's there. It's designed to cut through the air, be nice and streamlined through the air. That doesn't necessarily mean that you're not going to have drag here, okay? If you have something that perturbs air, it's going to create drag. Anything that moves air in one direction or the other. It makes a ton of drag up at the front of the vehicle. Drag is basically low pressure air. right? Or turbulent air. So the air is going to come at this thing, Victor, right? And the nose cone is going to push it out of the way, right? It's going to hit the nose cone and it's going to shoot off to the side. Or it flies down the nose cone and then it goes over here like this, right? It leaves a wake. Think like a boat going through water. It leaves a wake. You will leave a wake here. That wake makes drag. That drag is an effective force on your vehicle. It's a force that's pulling the nose, right? So if I go to turn the vehicle, right? All that drag up at the top of the vehicle when we're going to gravity turn is going to make us flip because there's not enough drag. There's too much drag at the front of the vehicle and not enough at the back. That phenomenon is called your center. Well, it's your center of pressure. Your center of pressure, because you're flying through the atmosphere, is dynamic. The reason why it's dynamic is because pressure can dynamically build up on certain parts of the vehicle. That's what max Q is. I'm sure if you've watched rockets fly, you've heard max Q get thrown around a little bit. Max Q is basically when you have a pressure that's built up on the front of the vehicle where the structural mode of the vehicle can't, well, if you tried to accelerate anymore, the rocket would accordion like a cartoon character. We don't want that. You'd have too much pressure build up on the front, and potentially your center of pressure moves too far forward. And if your center of pressure moves too far forward, your rocket's going to want to fly tail first, right? Fins at the back counter that force. The fins basically streamline the air, and they do to an extent push the air to the sides in real life, right? They push the air around, but they're disrupting the air down at the bottom of the vehicle. Disrupting at the bottom of the vehicle keeps you nice and streamlined because it keeps your center of pressure, well, low. You don't want your center of pressure being too far at the back of the vehicle either. Like if your center of pressure is over here, you're making too much drag. You got to find the balance between having too much wings down there and having not enough, right? I chose 3 because that stabilizes us on yaw, pitch, and roll, right? Now these wings don't move, they're fixed, okay? But these wings should keep our center of pressure in line. So let's take tutorial 1, let's put it back on the pad and let's see what it does this time. This time, I'm gonna send it full throttle the whole way and let's fly it up into space and see what happens. Like an arrow, exactly. If you look at an arrow that an archer would have, you have your nose cone up at the front. Your nose cone is heavy, right? It's usually, the arrowhead on an arrow is usually made out of made out of metal, right? And then at the back, you have stabilizers, and that keeps the arrow flying correctly because it puts drag at the back. Because the nose cone is going to move the air. You don't want drag at the front of the vehicle. You want to create drag at the back. Now, heading lock, full throttle. Let's activate the engine. 3, 2, 1. So the further back, the better. Yes, let's go. Now watch. Watch this. I'm at full throttle. We're going. Tutorial 1 is flying. Why not have a more aggressive gravity turn? I couldn't take a more aggressive gravity turn without the vehicle flipping over, but now we can. So if you want to see this visualized in Kerbal, you can hit F12 and you could see arrow forces, the wings using arrow, right? Or you could see which aerodynamic direction the vehicle is pulling in. Freeze it, tank. All right, look. The blue is lift that the wing is generating, okay? Red is obviously drag. Right? We can go in here and we can take a look. See? Our nose cone is creating drag to an extent, and that drag can destabilize us. But the wings down here, stabilizing us and moving the center of pressure downward, right? That's counteracting that force that's tugging up on the top of the vehicle. Basically, it's trying to tug us this way, and the wing is basically tugging us that way with that aerodynamic force, and it's keeping us flying on an even keel. Now you also see at the back of the vehicle, we're generating a ton of drag because it's the back of the vehicle. The whole point here is to keep the drag low. On a rocket, you want to have the drag down here. Now, more advanced designs have other ways of getting around, more advanced rockets have other ways getting around aerodynamic instability. I'll show you. Just because this works for us in KSP doesn't mean in real life, right? That doesn't mean in real life that there aren't weird looking rockets that look very aerodynamically unstable that still fly. Well, let's say fly, quote unquote. There's no fins down at the bottom of this thing. That is a big, thick upper stage on top and an SRB behind it, right? But Ares 1X flew just fine. I mean, after the engine shut off, it did something weird after that, but see, look. That doesn't look very aerodynamic, but it works. There are other ways to get around it, but we're keeping it simple here. This works. Now watch what happens if I try to... See? Keeps us nice and stable. Hang on one second. What's up?
Hey.
Hey, Ben.
I found a little bunny nest.
You found a bunny nest, buddy?
Yeah, right outside. You remember when the dog pulled me over?
Yeah.
It's right around there. Like, under some leaves and stuff. So right outside your door on the hill.
Yeah.
That's where it is.
Hi, Titan. My dog and Brimo are here. Titan and Brimo are here to see me. My dog and my wife. Oh, Bubbles. Come here. Can you come up here? Can you come up here, Bubbles? Come here. Hi. Hello. He's busy. What?
I don't know what to do out there. I feel like...
Give me 1 sec. I'm discussing dinner plans. I'll be back in a second. Okay, dinner plans have been finalized. What do we want? Don't know yet. We'll figure that out. That was the plan. The plan is to finalize a plan to figure it out later. Might come back to bite me, who knows? All right, so check that out. Look, see? The wings are gonna pull against the aerodynamic forces up at the top of the vehicle. Gonna keep us nice and stable. Show static stability by shutting off the SAS. Well, we're not going to get any more of that because we're going out of the atmosphere. Now, you see something funny going on here. Isn't that re-entry heating? Yep. Yes, it is. Parts of the vehicle are going to heat up if you go up too quickly. Just like when you're coming down fast from re-entry, right? Coming fast from re-entry, stuff's going to burn. This is the problem with, like, just as an example, like why we don't have planes that fly up into the atmosphere. Or like fly up into the upper atmosphere and then fly up into space. Because you go too fast, too low, right? And if you're going fast too low, what happens is you get shock heating on the vehicle. You'll start to experience re-entry heating. Now, what is this? What is re-entry heating even in the first place? Okay, and why is it happening here? Well, there is still air up here. See the pressure indicator? There's still air. It's not a lot, but it's still air. What's happening is we're going so fast that air is compressing up against the front of the vehicle here. And when it compresses up against the front of the vehicle, it ionizes. If you're going fast enough, the air compresses so much that it starts to basically rip apart. And that resulting ionization generates, well, at first, from a compressed gas, it generates heat because compressed gases heat up per the ideal gas law. That's PV equals nRT. That basically states in cool math terms that when gases compress, they get hotter, and when they get colder, they decompress. When they decompress, they get colder. That's the right way to say that. So, what's happening here is that we're compressing gas up against the front of this nose cone. Remember, I said the nose cone has to push the air out of the way. Air is getting compressed up against that nose cone because the air coming behind it, it can't move out of the way fast enough before the air behind it hits it and pushes it up against the vehicle. That compresses it. And if it compresses too much, it's going to ionize, and that's going to generate plasma. That's what re-entry heating is. Right? Plasma, to say that plasma gets hot is kind of an understatement, but that's what's going on here. You're getting shock heating, right? That's basically from us going too fast, too low. I mean, you could do it. Like, all rockets do experience this to an extent. We just don't see it. It's just enough to compress the gases up against the vehicle. It doesn't make re-entry heating. But yeah, this isn't that big of a deal, but this is us punching out of the atmosphere. Ideally, I don't want my rockets getting re-entry heating on the way up. It does happen, though. But if you look, it's going away. The reason why it's going away is because we're getting high enough in the atmosphere where, well, we're getting high enough above the planet where there is no atmosphere. Oh, that's a temperature indicator on the front. Got a little warm. All right. We gonna have enough? Close, but no cigar. So we gotta really screw around with our trajectory here. That was close, but we didn't make it. Even when I pointed the rocket in a direction to try to get the most opportune burn, which is more or less point at the horizon and go. Tutorial 1 still didn't get into space. Okay, no problem. Let's try again. Let's fly a little bit of a different trajectory this time. That time I was showing you guys Aero. Let me see if we can fly it on a really nice trajectory. Now, in Kerbal, there's kind of a trajectory. There's kind of an ascent trajectory that for the most part works, right? It works as follows. All right, SAS on, throttle up. Engine is on in 3, 2, 1. There we go. We got a good liftoff. Tutorial 1 is in the air. Again. Hey, Ansel. Yeah, the SR-71 did experience shock heating. The Lockheed engineers' kind of workaround for this was to make the entire airframe out of titanium. And even then, it still got too hot. You know how hot you need to get to melt titanium? That's pretty hot. Alright, so I'm going to keep us throttled up. Remember, we want to get out of the atmosphere as quickly as possible. Oh, see, we're going a little too fast. We have some we got some vapor coming on the vehicle here. Let's slow it down a little bit. Let's throttle down. Let's just go nice and loosey-goosey here. Don't you need to roll? Not really, Green. Just fly due east. Rolling on rockets in real life is just used for vehicle orientation. If you, like, for instance, if you have antennas on the vehicle, you want your antennas pointed downwards because the receiver antennas are probably down there. All right, so at 25, you want to be at about, so at 10, you start to pitch over. 10 kilometers, you start to pitch over. At 25, you want to be at about 45 degrees. And then, once you get past 25, by the time you get up here, you get 35, you start burning for the horizon here. Let's take a look at our trajectory this time. The idea is to not make your AP, your apoapsis, or your high point in your orbit go too high, right? We want to, remember, we're up in space now. It's not about going up, it's about going fast. Right, so we turn and burn towards the horizon here. Let's just throttle it. Throttle it a little bit. Now see how the AP is moving away from us instead of up? It's moving forward, not up. I mean, it's still moving up a little bit. Right? I mean, Green Leader, like I said, you don't necessarily need to roll. Rockets do roll programs because sometimes they're going to different orbits, but with this, no, not really. All right, throttle it down. All right, let me just turn a little bit in because I want to keep my AP moving away from me. I don't want it going up necessarily. And, oh! Welcome to orbit. We're there. Look, once we started going fast enough, above 2,300 meters a second, see what I'm talking about? This other thing popped up over here. That's called a periapsis. When your periapsis pops up, that means you're close to getting into orbit. When your periapsis goes above 70 kilometers or 70,000 meters, that means you're high enough above the atmosphere to stay up here. Now we're in space. Look at how much fuel we had left. 2.17 units of liquid fuel left in oxidizer. You're in space. There you go. Pretty cool, huh? That wasn't too bad, right? Now let's try to go literally anywhere. Oh. Oh, we're out of fuel. What do you think of beginners hitting sandbox and using MechJeb? You could play sandbox, and if you want to use MechJeb, fine, but I think using MechJeb in KSP is like using aimbot in Counter-Strike. It doesn't really teach you anything. Like, you're kind of missing out on playing the game, like, by doing that, but if that's how you want to play, there's really no wrong way to play Kerbal. Hey Maz, what's going on? 128 months. If you bring an iPhone with you, the highest point is its apoapsis. I get it. So, check it out. We're in space. So is it that easy? Well, yeah. I mean, it's really not that bad. But you got to remember, now we're stuck here. Now we're stuck here. We ain't going anywhere. We can't do anything. We are in space. We made it up into orbit, but we essentially just sent a missile into orbit, and that's it. Right? Can the trajectory for the descent be programmed? Yes. There is a mod that I use called KRPC. You can code a guidance system for your rocket in Python if you really want to, and then compile it into KSP and have your rocket use it. SpaceX can rescue you. Yeah, right? Your dinner plans sound like Mars sample return plans, yeah? Violent, you are here in your new house, and at night I can see some lights in the sky, but how do I know if they are stars or satellites? You ever heard the song Twinkle Twinkle Little Star? Stars twinkle. That's why that song exists. If you look up and it seems to be glistening, that's a star. If it's not glistening, it's a planet. If it's not glistening and moving across the sky really fast, it's most likely a satellite. Seriously, go look. You want to know the difference between a star and a planet, see if it's glistening. If it kind of looks like it's shimmering, that's a star. If it's not shimmering and it's kind of staying there, that's a planet. If it moves fast and it blinks and it appears to have red or green lights, it's most likely an airplane, yeah. Yeah, if you see something up there that's not glistening and it's red, it's most likely Mars. If you see something up there that's not glistening and it's green, it's either Venus or Jupiter. And why is that? Xenomorph, long story short, mark one eyeball. That doesn't happen like if you look through a telescope. That's just how that's our eyes doing that. The Death Star made planets twinkle for a bit. Yeah, okay. Now, another thing is that, like, you can see shooting stars. Shooting stars are something that streak across the sky and leave a trail behind them. That's most likely just an old satellite. Or it just could be something re-entering the Earth's atmosphere. It could be a rock or a piece of ice or whatever. It could even be poop. It could be urine. Yeah, we call them Boeing bombers. It could be any of those things. Shooting stars are just something re-entering. But an important thing to understand is that just because you saw a shooting star doesn't mean that it's like a satellite or something. A shooting star could be just a meteor that's re-entering. Fair enough. Didn't mean to be rude. No. It's all good, man. We're good. You didn't come across as rude at all. That's just how our eyes see it, dude. Like, I don't really have a better way of explaining that. Stars don't twinkle if you look at them through a telescope, dude. Yeah, no, all good. Mark one eyeball. You're not coming off as rude. That's a legit question. Hey, EJ. Hey, EJ, out what causes the wiggliness in a rocket in KSP? Lack of struts, dude. W stream, by the way. Thanks, man. Are we getting any BF6 gameplay for After Hours? I don't know. I may or may not have promised my wife that I'd make her dinner, so I'll think about it, Warwolf. I'll think about it. We'll see. So, tutorial 1 is in space. That's great. Lovely. Now what do we do with it? Well, we can't do anything with it. We're stuck in space until we run out of power, in which case we have space junk. We don't want that. So, in our engineering mode save, we could just hit the rewind button. All right. So this has enough to get it into space, to get itself into space, but that's it. It has enough to get itself into space, and that's all. Now, here's where this gets a little tricky. This will get to space. But getting this entire thing up there is kind of useless. That's all right. Great. Good. We want to move a payload, right? We want to move a payload into space, right? That's the whole idea here. Okay, so let's bring tutorial craft 1 back over here. All right, now let's ready? Now let's modify our tutorial 1 craft. I have enough craft files in here. In Kerbal, you ideally want to move something up there, right? Let's think. What do we want to move? Space junk is a hot topic right now. Too soon. Yeah. An orange fuel tank? How about we start with something a little bit smaller? All right, so let's take the nose cone off, right? And let's put a payload up at the front. Now, for the sake of this, guys, what I will do is we will just use a fuel tank. I'll have a fuel tank as our payload. So this is 1.1 tons. That's 1.1 tons of payload, okay? Now let's put that up there. And remember, we want to be able to deploy our payload, right? So let's put it on a decoupler, right? And then maybe put the nose cone up at the top. Pretty cool, right? That's fine. We want to be able, like I said, we want to be able to deploy it. Oh, no. Let's deploy the probe core and our payload. So if you want to use the fuel tank as a mass simulator, right? You just click on the fuel tank, place it, right click on it, and close its tanks. All right, so let's just move that down there. All right, so we have our payload up here, and then we have our rocket behind us. Now, let's take a look. We put 1,100 kilos of payload there. Look at our delta V number in the bottom right. Remember, we need 3,400 meters a second delta V. Adding that payload took us from 3,392 down to 2,728. Now we don't have enough. Now we're not going to get to space. We don't have enough. This is where staging comes into play, okay? And depending on how you want to do this, you got to find the balance, right? If we flew this right now, it's not enough to get into space. It'll get us close, but it's not enough. So let's try to keep it simple. Maybe we do this. Maybe we get rid of that and we put this down here. Maybe we extend our first stage. We can extend the first stage. That gives us 3219. That's close. But now we got a little bit of a problem. Remember that ascent flight that I took a second ago where we kept the engine throttle low and we were going up very slowly and gravity was pushing us down while we were trying to go up, and we ended up not having enough to get there, right? We didn't have enough. If we look down here, you can see another indicator here called TWR, thrust to weight. In this particular scenario, with 3 tanks stacked on top of each other, our thrust to weight ratio is 1.04. So remember how I said that rocket science, or with rockets, it's about mass. It's not about weight, okay? But what did I say that weight was? What's weight? It's the force of gravity affecting him on a mass, right? So what's thrust to weight? Hey, Zelly. Thrust to weight is the amount of force that the rocket is pushing up on relative to the force of gravity pushing down on your vehicle. If your thrust to weight ratio is above 1, you'll go up. If your thrust to weight ratio is below 1, you're not going anywhere. Your rocket isn't strong enough to push against the force of gravity. Now 1.04. That's not a lot here. So let's take tutorial 1 again with our 1 tons of payload up at the top, right? And probe core. Let me show you what 1.04 TWR does. Now, once again, it's important to understand we don't have enough delta V to get into space. But not enough delta V coupled with 1.04 TWR means we are going to go up at a snail's pace. Not ideal. Maybe some detachable boosters. That might be a good idea. Slow and steady wins the race, right? Not with rockets. Look, we're 40 seconds into flight and we're barely a kilometer off the surface. Now, as the rocket drains fuel, your thrust to weight goes up because as you drain fuel, there's less stuff to move, less mass to move, right? Our TWR is already at 1.45, but at this particular point in time, we have 1.5 TWR with 2754 meters a second delta V left, and we're going 129 meters a second at 2,800 meters. We've already burned a third of our fuel here. There's no way we're getting to space. Let's try to turn on our improved trajectory that we had. All right, we're doing our improved grav turn. Now keep in mind, I do have a couple of visual mods to make the rocket engines look a little bit better, but the gameplay is exactly the same as regular KSP. Now take a look. See? This is the thing about staging. Look at how much empty fuel tank I have. Okay? We have a single stage here. Look at how much of that. See all that empty fuel tank? I have 3 tanks, and each one of them is for the most part 3/4 empty. That's a lot of empty tank to be moving around. Now, like I said, once the atmosphere gets out of the way, we can get kind of efficient here. Oh, it's got a little bit of heating there, just a smidge. Look at our trajectory again. Looking pretty good. Oh, close. We wanted 2,300. We only got up to about 2,100. And then, watch. Boom! Payload deploy. But we deployed it on a suborbital trajectory. They got a word for this. Rockets that go up, deploy something once, and then come right back down right after that. They got a word for it. It's called a missile. That's basically what we just made. So, how do we get this up into space? Well, enter staging, okay? We need staging. That's called Blue Origin, right? Oh. Ooh, spicy. Spicy. New Glenn. Dude, in both chats! In freaking both chats! What's wrong, dude? What's wrong with you guys? Oh my goodness. They're freaking both YouTube. You guys are freaking so screwed up. Dude. Oh, now to be fair, man, did they screw the pooch. Holy crap. But also, like, so mean, dude. Oh my goodness. They're freaking both chats, bro. You gotta be kidding me. I'm sorry. That's really funny. So, if you're watching this VOD potentially in the future or you don't get the joke, this was right after New Glenn launched its third mission, and the second stage didn't good at all. Little embarrassing. Yeah, Blue Origin lost a customer payload, which is never a good day. Never a good day as a launch provider. All right, so can we give this a little more of a kick? Yeah. You guys want more boosters. Okay, you get more boosters. We need to increase our thrust to weight ratio, right? Now, what's the ideal? What's good? What's a good thrust to weight ratio? Most rockets have something a little bit north of 1.2 TWR off the pad. Some rockets get off the pad quicker than others. Starship is like 1.4. The shuttle was 1.3. Saturn V is 1.1. It was a little bit on the sluggish side. You really kind of want between 1.2 and 1.4. Depends on the rocket. Remember, the first stage is about going up and going up fast. All right? Your second stage is about going horizontally and going fast that way. Your first stage is trying to get you out of the atmosphere quickly, because the less time you're in the atmosphere, the better. But you're balancing against that center of pressure thing that I was telling you about, what's called dynamic pressure on the front of the vehicle. And you're also balancing that damn re-entry heating thing. You don't want re-entry heating on the way up. That's the reason why rockets throttle down on the way up, and why they start in the vertical position, because it's going up. You want to get away from the atmosphere. That's what your first stage is all about. Now, you guys, I was going to put a second stage on this, but you guys want to do something a little bit different. All right, that's fine. So here's what we're doing. Let's go to our coupling mechanisms. And instead of an inline decoupler here on our tutorial rocket, how about we put a radial decoupler? Let's take a radial decoupler and put it in 3 times symmetry. So we have 3 radial decouplers. This is a side attachment point that you can jettison. So let's go down here. How about we add some solid rocket boosters to the side? Okay, let's put some SRBs on this. Vulcan uses SRBs. Atlas uses SRBs. It's fine. Now, do we want our 3 SRBs to just have a blunt front like this? No. With that blunt front, you're going to a lot of air will get stuck right here. You want to get it away from the vehicle, right? So let's give it some nose cones. But unlike the nose cone at the front, there's a tilted nose cone. It's the nose cone type B. So we can kind of tilt them in to give our rocket kind of a more aerodynamic profile here. Now let's see what we got. So let's move that up there. Put the SRBs in the same action group. That's going to generate 2.83 TWR. And the burn time is 24 seconds. Let's see if that gives us enough delta V. But it's only going to do it, only going to do it for about 24 seconds. Let's take a look. Who thinks it's going to blow up? Is it going to blow up? Are we going to make it? Is there a wind tunnel? There's a mod for wind tunnel, and I have wind tunnel installed, yes. I won't show that because it's a mod. You're just getting into Kerbal. That's just going to confuse people even more. All right. Ready? Throttle up the liquid fuel engine in the center. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. My brains are going into my feet. Okay, the SRBs are out. Separate them. Okay. Oh, they hit each other. We're good. We're all right. We're alive. Oh. Woo! All right, let's fly that good trajectory that we were talking about a little bit earlier. Could a human even survive that? I don't know. Let's hit F3. 3.9 Gs? Yeah. Yeah. It would... You'd feel it, but yeah, that's fine. I mean, you'd feel it. Oh, you'd feel it. So let's see. How high were we when we separated the SRBs? That bought us 10 kilometers. We were up, yeah, see, we were up 10 kilometers. There you go. Sustained at 24 seconds? Yeah, you'd be all right, IT guy. You'd feel it though, but yeah, it would hurt. You'd feel it. I am not a software guy, Ace, so how good have I been with an Ascent program? Not very. All right. Will we have enough? Is it 8 or 9 Gs before bad things happen? 9 Gs sustained, Jay, is probably something you don't want to do for like maybe more than like 10 to 15 seconds. Have you ever thought about it though? I did do a couple of KRPC streams, dude. And actually, Ace, it would be really nice for me to automate my shuttle. My shuttle would... Here, I'm throttling back a little bit. Oh, look at that. We have a PE. There we go. We have 1,000 meters a second left. You see what just happened, guys? You wanted boosters. Do you see why some launch companies still opt to just put boosters on the side of the vehicle? Look at what it did. Not only did we have the payload up in space, but we got the entire rocket up there with 1,000 meters a second delta V. In Kerbal, guys, this is enough to go to the moon. Maybe not go anywhere past that, but... When will you play more Workers? I don't know. Kerbal's... I want to go back to playing Kerbal. Workers was my vacation from playing Kerbal for a little while. Do the free return? No, I'm all right. Could you have throttled down... You could have throttled down those SRBs in the hangar? Sure. But the SRB, even attachable SRBs here, guys, they show you the benefits of staging. After the SRBs flamed out, I separated them. And then we basically had the rocket up at 10 kilometers already going really, really fast, right? And that's the benefits of staging. And that's why people use SRBs. Now, check this out. This got us, we have 1,000 meters a second delta V left here. With our payload intact, we could send this to the moon if we really wanted to. Now, here's the thing. If I added an upper stage here to this design, right? If we put an upper stage on top of this, we could triple our payload amount. Easily triple our payload amount with pretty much the same vehicle. So this got us 1,000 1,000 kilos or 1,100 kilos up into space. That's, I don't know, like 2,400 pounds. Why? Well, look, even though we made it up into space, XJ, look at how much empty fuel tank we hauled up into space. See that? Look at it. Look at how much empty fuel tank we have. We lugged all this empty fuel tank up here. For what? To deploy the payload? We already did that. Now check this out. Let's go back down. Let's take tutorial 1 and let's screw around with it a little bit. Okay, so how about we take the exact same design? Now remember, we had 1,000 meters a second delta V up there with the payload in space, okay? So how about we take it and how about we break it in half? All right, let's go into the hangar. I like working in the hangar. How about we take tutorial 1 and we break our center stage now because you guys wanted boosters. So how about we take this and let me put an engine on it. Heck, let's take the exact same engine. Let's use the same thing as we used, the same LVT-45 that we used for the center stage. All right, let's put that there. And then let's add a decoupler again, right? Watch this. Nope, that's not the right one. See what I'm talking about here? All right, now we just split that center core into a core stage and then an upper stage. All right, now we have to go over here. We have to check our staging here. I don't need to separate my upper stage and light all my engines at the same time. We don't want to do that. So let's go over here. Go here like this. Check your staging, right? This is an old Kerbal. There's an old Kerbal slogan that's called "Check your staging." Check your staging. You don't want to do a Mercury Redstone 1 and activate the wrong thing when you're on the launch pad. Now, if you want to see something funny here, look. So, in the 60s, in the early 60s, NASA had Mercury Redstone. Mercury Redstone was the rocket that Alan Shepard would fly to get up into space. Not orbit, up into space. This was the first Mercury Redstone rocket. NASA put it out on the pad, fueled it up, got everything ready to go. Watch this. Separated the umbilical. Yep. There's the parachute. That's why you check your staging. That's why you do that. Because you don't want to deploy your parachute for your capsule when you're on the pad. Now, what happened with them is an electrical short triggered the launch abort system. There was an electrical short during ignition with one of the vehicle's electrical systems, and the short circuit activated your launch abort system. And the launch abort system fired the launch abort system and then deployed the parachute. It's kind of funny. That's why you check your staging. You don't want to do that. Right? So let's check our staging, right? Get into a habit of doing it before you put the rocket out on the pad. So, lesson learned. Yeah. But it didn't stage the capsule. Yeah, electrical short circuits do that. So if you saw that, the rocket actually fired, went up like a ½ inch, and then came back down. They are so lucky that thing didn't blow up. Anyway, so take a look. We have all of our engines ignition. All the engines start at ignition. Then we separate the 3 SRBs. And then when our core stage runs out, right? We separate it, fire the upper stage engine, which once again, that's the same exact motor. I just have the same motor stacked on top of each other, okay? Now, remember, this exact same rocket design, the same thing here, okay? We got into space with 1,000 meters a second left in the fuel tank, right? And our payload of 1,100 kilos. All right, watch this. All I did was split it, put a decoupler and an engine in, and split the third fuel tank away from the other two below it. Watch what happens now. We do have the extra weight of the engine and a decoupler, but that will drastically outweigh, pun, the extra mass of pulling all the fuel tanks up. Watch, ready? 1, 2, 3. Now our TWR isn't nearly as bad as it was before because we added a little bit more mass. We're still going up really quickly though. Those SRBs really pack a punch. Turn. Oh, stay together. All right, separate. Ooh, the SRBs hit each other. Why did you count up instead of count down? Because it's my rocket and I can do whatever I want. The angled noses made them glide. Yeah, because I jettisoned them in the atmosphere. They're still under the still subject to the forces of aerodynamics, right? The other thing to take into account is that we're dumping the wings. We don't need wings. Wings don't do anything in space. So when this stage does run out, right, we're separating the wings because we don't need them. All right, stand by for staging. There's engine cutoff, stage separation, upper stage ignition. Here we go. Something like that, damn it. Now remember, we had a kilometer a second delta V in orbit, right? Okay, there we are. Look. That was a horribly inefficient way of doing it, and take a look. We added another 154 meters a second delta V to the design just by doing a stage. And we can make that, we can get even crazier with that if we optimize it. If we take the engine and we put in an engine that's better suited for up there than it is down here. See? We added an engine and we gained 154 meters a second. TX, 100-month resub. Thank you. The best thing that came from you playing Workers was all of the great Bakalaka Daka tunes. Oh, jeez. See? We dumped all that extra fuel tank. Now, I would argue that we still have a lot of wasted fuel tank here. So we could hone in the design and we could dial it in more. How do you know if an engine is more efficient in space? That's a good question. Bim, I was going to get right to that. And like I said, we didn't gain much there, but that was on purpose, right? The point was to show you that even with adding an engine, you'd think that adding an engine would be more mass. No, the mass of the engine is less mass than the mass of all those ridiculous fuel tanks and all those wings. Not by much, but it is. And even though we added mass to our design, it's still more efficient. We went further. We could accelerate faster. We could accelerate to a higher speed. We had more delta V. Now, engines. What makes a good upper stage engine and a good first stage engine? Well, I'll explain it in Kerbal, and then we'll explain it how it works in real life, okay? So in Kerbal, the number that you want to look for, let's take the LVT-45, the engine that we've been using. Remember how I said you could right-click on this and you could keep the window open? The number that you're looking for is something called ISP, okay? Specific impulse is what it's called. What does specific impulse mean in plain English? How fast can you shoot stuff out the back of the rocket? If you can shoot stuff out faster out the back of the rocket, you're more or less more efficient. Yeah. I mean, that makes sense, right? If you can shoot stuff out the back faster, you're gonna accelerate further. You're gonna have more change in velocity, right? Like, that makes sense, right? If we really want to get into specifics, specific impulse is how it relates to how much energy you can get out of a certain quantity of fuel. Now, let me pause the music for a second. In Kerbal, you have one type of fuel. You have liquid fuel. So you really just want to look at your engine specific impulse numbers, and you want to find a higher number. Now, let's take the LVT-45, for instance. 250 seconds at sea level, 320 seconds in vacuum. Rocket engines tend to be a little bit more efficient up there, no matter what the design or what propellant you're using. They tend to be a little more efficient up there. The reason for this is because up there, you're not pushing any atmosphere out of the way when you accelerate gases out the back. Rocket engines down here are subject to something called the Coanda effect. We're getting into very rudimentary aerodynamics here. Let's go here. Let's go here. Right? Long story short, you kind of have to, it's not necessarily Coanda. Coanda is more because of the drag at the back of the vehicle. Give me one sec. Let me find what I'm looking for. How about, all right. SpaceX released a video a long time ago of their past missions. So it's not, like I said, it's not necessarily because of the Coanda effect. The Coanda effect is what happens when you shoot, when air is going at high speed relative to air at lower speed next to it. It kind of pulls it with it. But, so look, this is footage of a Falcon 9 taking off. It's a really old Falcon 9. But let's take a look at the exhaust. What can you tell me about the exhaust other than it's really, really freaking pretty, right? Specifically, look at the shape. What's the shape of the exhaust coming out of here? It's very narrow. It kind of goes out and then it comes back in. See? It's kind of forming a you know, kind of like an hourglass almost. See that? It tapers inwards over time. The reason why that's happening is because the massive, or the weight of the atmosphere is causing those gases that are being shot out of the engine, right, to collapse in on themselves. It's the same reason why if you have a balloon full of helium and you let it go, it goes up, right? Because helium has less mass than the other gases, and it'll go up, and the gases will displace its position and push the balloon upwards, right? Rocket engines, down here, they're not as efficient as they are up there. Because remember, it's about stuff getting in the way. It's about how fast you can push that gas, or, well, fire in the case of a rocket engine. How fast can you push stuff out the back, right? When you're pushing stuff out the back, the atmosphere makes your exhaust plumes collapse in on each other, collapse in on themselves, right? So the atmosphere gets in the way. That's the short way of saying it. Rocket engines, when they're up in space, you don't have that problem. Right? Because there's no atmosphere up there. See how even during this ascent with Falcon 9, how the rocket exhaust is more or less a column. As the rocket gets higher, your atmospheric pressure drops. There's less stuff to get in the way. There's less atmosphere to push in. So your more or less kind of conic flame that, or not cylindric flame that's coming out of it, out of the rocket engine, it ends up being more conic. The reason why is because the gases can get shot out at high speed. They don't have to worry about hitting anything on the way out, like hitting atmosphere on the way out. And the lower pressure allows those hot gases to expand and just get away from each other. So once again, I knew someone was going to ask this question. So that's why I teed up this footage, right? See? You see, even in the upper atmosphere, it still is kind of tapering in on itself. That's more because of the 9 engines. The center engine is making this effect right here, but that's another story. I knew people were going to ask this question, and that's why when I explain specific impulse to people, it's how fast you can shoot stuff out the back. If you could shoot stuff out the back faster, you're going to be more efficient. Right? See, look at when it gets up towards engine cutoff. Take a look. Look at how much those gases are expanded. Now, one of the reasons why the gases are the gases are expanding like crazy is because the center engine on Falcon 9. Falcon 9 has 8 engines with 1 in the center. 9 engines, Falcon 9, right? That single engine in the center is all of it, it's pushing out all of its exhaust gas, and that exhaust gas wants to expand, and it ends up pushing the other 8 engine plumes kind of outward because of the low pressure. There's staging, and actually, that's really cool. But what you're seeing here is the first stage. After staging, the first stage on a Falcon 9 turns around for the people that don't know. The first stage actually does a 180, and the first stage refires its engine while the second stage is going away. And what you're seeing there is the plume interaction in the upper atmosphere of the first stage exhaust and the second stage exhaust hitting each other. It's one of the coolest things that you can see, but you don't see this all the time. One, because Falcon 9 doesn't. The first stage, this is what's called an RTLS mission for Falcon 9. An RTLS is where the booster comes back and lands on land as opposed to landing on the drone ship. So, and there has to be specific lighting conditions. Like this has to be done at dusk to see it like this. But watch, when you do see it, it's one of the coolest things. Watch, look at that. Supersonic retro propulsion. Isn't that cool? And see, the first stage coming back down to land is down, it's back down here in the atmosphere. Look at its plume. See what I'm talking about? The plume is back to being more cylindric in nature. I really hope this doesn't get flagged. Can we play this with the music? It's so much better with the music. All right. Ready? Falcon 9 deploys its landing legs and everybody has a good time. Pretty cool, huh? Yeah, that SpaceX video is really good. I really wish they'd post more stuff like this, but I'm sorry. This part of the video, when this slow-mo footage of the first stage coming back in, that's just. And then the drop, like. Yeah, that's sick. That's still cool. Dude, we've seen 600 Falcon landings and change. It's still cool. Like, I still think that's really neat. Like, but then again, I'm the kind of guy that like gets a little fired up, like when I'm flying on an airplane and they get on, they taxi onto the runway and they have, they throttle the engines and then just you hear the. And I'm like, yeah, let's go, man. So I don't know. Maybe I'm just easily amused. Could be that. It's still cool. It's still cool. I'm sorry. It's still freaking cool. But anyway, now getting back into upper stage engines. Let's get back to the tutorial. So, all right. like any engine tends to be more efficient up there, but in Kerbal, there are engines that give you higher specific impulse in your vacuum. Now check this out. What I'm going to do is I'm going to take the swivel engine, which has 320 seconds specific impulse in vacuum, right? So up there, where there's no gases, it's 320 seconds, okay? So that's pretty efficient. How about we swap it with a Terrier engine? The Terrier engine is an upper stage engine in KSP. It doesn't make as much thrust, but it has 345 seconds specific impulse. It is much, much, much more efficient. So how about we do that and we put the Terrier engine in there instead. The Terrier engine is also less mass. It's 500 kilograms to the LVT-45's 1,500 kilograms, right? So we just made our rocket we made our upper stage more efficient, and we took mass out of the design, meaning that there's more fuel on our rocket and less rocket on our rocket in the upper stage. So now let's see what our tutorial 1 rocket does with the better upper stage engine. Let's take a look. Switch it back over here. Turn the music back on. What is specific impulse? Specific impulse is the efficiency of the engine, okay? The efficiency of the engine. It's measured in seconds. This is I already kind of explained it, Tanit, but it's fine. Hey, Stavlin, 80-month resub. Slackter had a 62-monther in there, too. Thank you. You call the plume interaction a Falcon Nebula. Yeah, AJ, hell yeah. Yeah, baby. We lost Delta V, though, didn't we? Well, yes and no. It's losing Delta V because the Delta V calculator is calculating for altitude, right? So our upper stage, if you look, it says 830 meters a second. That's what we would be getting if we operated the Terrier engine, right? If we operated the Terrier engine down here, it's not very efficient. Look at its specific impulse in the atmosphere. 85 second specific impulse. It is horribly inefficient down here, but it's a great upper stage engine. It's good for up in space, right? Now, specific impulse is akin to your miles per gallon, okay? It's your efficiency of your engine. So like if a car gets more miles per gallon or kilometers a liter, I think is... no, it's not kilometers a liter. You guys use some measurement that doesn't make sense to me, but it probably makes sense to you, but you get what I'm saying. It's liters per 100 kilometers. Okay, all right, I get it. Metric system base 10. That is a why per 100 Ks. I don't understand. Why would you do that? And we still call it mileage? Really? I didn't know that, Tyler. That's funny. Kilometers a liter or liters per 100 kilometers. Mostly kilometer for 1 liter. Liters per 100. It should be kilometers a liter. Liters per 100 kilometers is dumb. Yeah, I don't understand. Can you explain bar to us, like PSI and chamber pressure? Sure, Nikki. Let's finish this and then we could get into it, dude. I remember the Cosmos SkyMed mission. Dude, we covered this. We watched this live here, Baron. I'll watch it just because it's cool. 10 kilometers a liter is like 23 miles to the gallon. All right, I'll explain that in a second. Yeah, Baron, we can... Yeah. Watch, there's engine cutoff. I remember this footage, dude. Oh, that is pretty good. There's the upper stage. This footage was tracked from the ground, man. Look, upper stage is firing its attitude control system. It's gonna flip around. And the Cosmos SkyMed mission, they landed the first stage back on land. Look, upper stage is getting ready to fire. Stiffener rings. First stage reactivated its engine. Second stage engine. Oh no, it was already on, excuse me. But yeah, there's your plume interaction. Watch, fairings will separate here in a second. Yeah, I remember the Cosmos SkyMed mission. This was sick, dude. Watch, they'll pop the fairings off. Isn't that sick? Bro. All right. Anyway, so specific impulse, dudes, is miles per gallon. It's your efficiency of your rocket engine. So it's your MPG. The higher that number, the more efficient your rocket engine is going to be. If you want like technical details, give me 1 second. If you want like technical details, the plain English way of saying it is how fast you can shoot gas out the back of the vehicle. How quickly is your jet going? It's very simple. You're more efficient if you can take a certain amount of fuel, like X amount of fuel, and use X amount of fuel to accelerate gases out the back faster. But yeah, specific impulse is derived from mass flow rate for the nerds. It's derived from mass flow rate and exhaust velocity and total impulse, which you use those three to figure out specific impulse. Total impulse is how much energy can you extract out of a certain quantity of fuel and oxidizer. What was the weather phenomenon to cause that clear imagery? This is insane. It was the trajectory, Cozy. That Cosmos SkyMed launched out of the Cape. And like, okay, so say this is Florida, right? South is that way. It launched out of the Cape and went south. So that camera was just on the peninsula and they were able to image it, the rocket heading due south because it flew alongside the coastline of Florida. So let's take a look at our specific impulse again. 345 vacuum, and the engine, we just knocked a metric ton out of our second stage because the swivel engine is 1.5 tons and this is 0.5 tons. So this is 500 kilos versus 1,500 kilos. So not only did we make our engine, not only do we have a more efficient engine up there, right? We also have a lighter engine, much less mass, right? So it says we don't have as much delta V up there, right? But that is because we have our delta V tool set to altitude 0. It's set to sea level. If we switch it to vacuum, watch the delta V from our second stage. It goes from 830 to 3370. The real mind screw is that miles per gallon or liters per kilometer or whatever it is reduces to an area or an inverse area. Nice, Baron. That's cool. For the Artemis 4 mission, is the idea to get us close to a polar orbit around Earth before TLI so we can hit the lunar South Pole? No. An inclined orbit around Earth will get you a polar orbit around the moon. Blark, the really quick and easy way of describing this now, okay, it is 1,000 times more complicated than this, but say you have Earth here and say you have the moon here, right? See what I'm saying? See what I'm saying? The moon is a lot smaller than Earth. So if you're in an orbit that's like this, right, and you shoot the moon, right, that's inclined, you're gonna fly out here and you can get into a polar orbit because the moon's smaller. Does that make sense? You don't... The moon is 1/6 the size, so as long as you're... If the Earth's equatorial plane is like this and you're in a tilted orbit, you can fly up and over and get around the moon that way. You can use the inclination just due to the differential size. That's the quick and dirty way of explaining it. Send this to the moon. We might have enough. All right, 1,100. We have 1,100 kilos of payload, and the number to beat is into a low Kerbin orbit with 1.15 kilometers a second delta V. Watch this. Okay, throttle up, staging is checked, fists are bumped, bumps are fisted, fist my bump. Ready? 3, 2, 1, ignition. Here we go. Now watch this drive. All right, everything's working real good. We're going a little fast here. We could probably tweak the thrust output on the SRBs just a little bit, but this is fine. All right, ready? Separate the SRBs. They all hit each other. Fist my bum. Amaze, 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 amaze. All right. Tutorial 1 is working very well. Could be more pointy? No, it's good. This rocket is not about instilling fear into your enemies. Hey, XP North, what's up, dude? Keep up the good work? I'm trying. All right, stand by for Miko. Okay, stage separation. There we go. Now, these are some good references. I love my references. You don't know me. Now, once again, this motor doesn't make as much thrust as the LVT-45, but it's 25 seconds specific impulse more efficient. That makes a big difference. The motor is also a lot lighter. It's 1,000 kilograms lighter. That's 2,200 pounds lighter. Just flying it a little bit, a little nicely here.
Discovery.
Bye,
Go
Builder.
throttle up.
44-month resub. Thanks, dude. Now look, we just made it up into space, and look, we have 2,190 meters a second delta V left. We have double the fuel on orbit just from switching up the engine. Make sure you use upper stage engines where you need upper stage engines and first stage engines where you need them too. But also, this shows the benefits of staging. We have enough change in velocity to get to the moon. We could land this on the moon. I don't think we did, Beansy. How's the bubble wrap? Let's see if it wants to play the sound clip today.
Copy.
Copy. Give me 1 second. Hang on.
Copy. Bubble wrap nominal.
There we go. There we go. We're good. Is there a way to reconfigure engines for vacuum once in space? I mean, Tenet, yeah, if you... There's no current way to do something like that, dude. But you could, like, if someone wants to go and make, like, a variable geometry style nozzle, sure. But you gotta remember, the nozzle is better... the nozzle's much easier to make if it's just one piece, right? Making some type of thrust vector control system like a jet engine might be a little bit tricky. The reason why it might be a little bit tricky is because the fire that comes out of rocket engines tends to be a little bit more spicy than what comes out of a jet engine. There's one engine with a nozzle extension that installs in flight. Could you do something like that? In real life, guys, your upper stage engines are going to... in real life, upper stage engines tend to work a lot like this Terrier, in that they work okay down here, but they don't really make a lot of thrust. You don't need a lot of thrust up there. You really don't. Unless you're trying to move something big, like think like a LEM in the CSM. So like think a Saturn V third stage. You don't need something too incredibly big. Hey Nazlik, what's up? Panderific, how you doing? I thought you mentioned we can't do a free return orbit from the moon in KSP due to... No, you can do a free return, Riv. You absolutely can do a free return in KSP. What you can't do is Gateways orbit. You can't do a rectilinear, near rectilinear halo orbit. You can't do that. KSP's physics simulation is not advanced enough to do something like that. But you can absolutely do free return. I've done it many times. I thought you did one. Mine wasn't rectilinear. Mine was just an eccentric polar orbit. We fudged it, Rarest. Do you have solar? As are you losing power? Nope. We could turn the engine on and generate some power that way. But see, look at how much extra we have now. Now, what we could do is swap that for payload capacity. Right? This rocket can only move 1,100. Right now. How about we double it? Yep, that'll still make it. We doubled it. Now we have 2,200 kilos. That's 4,400 pounds. It's almost 5,000 pounds, dude. Is that why they sometimes use a stubby nozzle on Falcon 9? That stubby nozzle was used on missions where they don't need the performance. Now, like I said, I said I would explain this in KSP and then explain it in real life. In real life, an upper stage engine needs a bigger nozzle. You need a bigger nozzle. The reason why generally you need a bigger nozzle on an upper stage engine is for the same reason why engines are more efficient up there. There's no atmosphere up there. There's no pressure. So if you think about a rocket engine working down here, you remember it has that column of gas. All of your gases are accelerating this way, okay? Because the atmosphere is kind of being a figurative like guardrail for it, right? It's going all that way. When you're up there, okay, there's no pressure. So with a nozzle, if you use the similar size nozzle up there, it would work. But a lot of those gases, because there's no pressure, will not go directly. Like if the rocket engine is pointed that way and gases are coming out, sometimes the gases will they'll come right out of the rocket engine and it'll take a 90-degree turn because there's no pressure and all the hot gases coming out want to expand, right? Just like that Cosmos SkyMed footage. If we go back over here, right? You see how they everything wants to expand. If the gases are going out this way or out this way, if they're going any direction other than being or parallel to the direction of the nozzle pointing, you're losing efficiency. Remember, it's about how fast you can accelerate the gases away from you. Accelerating the gases that way, that won't help you, right? So upper stage engines tend to have bigger nozzles. That doesn't mean you have to have a bigger nozzle up there, but they tend to have a bigger nozzle. Like if you look, Falcon 9, there's 9 engines right there. Now look at when they stage. If you look right there, look at how big the second stage nozzle is. Comparatively, it's almost as wide as the entire vehicle. That's because if you have a bigger nozzle, you can use that bigger nozzle to basically accelerate more of the gases away from you. So upper stage engines in real life tend to have bigger nozzles. They don't have to, right? They don't have to. There's upper stage ignition right there. But they tend to. Now, the reason why SpaceX opted for those damn stupid stubby nozzles of doo-doo, I hate them. By the way, it looks ridiculous. I know where I can find a good picture of one right off the bat. Give me 1 second. It's the Sonic Boom video. So, check this out. SpaceX, from time to time, has opted to use a stubby nozzle. They do that on missions that does not require as much performance, and the reason why they did that, you could see where the nozzle should be. The nozzle should be riding in this channel right here, but it's obviously not. Use that damn stupid stubby nozzle. I hate it so much. It looks so stupid. They use that when they don't need the performance. The reason why they were doing that is because there was a shortage of... SpaceX ended up making so many damn upper stages, there actually ended up being a shortage of the materials that they used to make the nozzle. Niobium carbide, if anybody's wondering. Yeah, I know. Also, I'm going to watch the Sonic Boom video because the Sonic Boom video is cool. XP North, what is your question? Do you know what type of avionics systems they have on board Orion? It's a custom software suite, dude. Were they strictly made for Orion? Yes. Or could you find these on other forms of spacecraft? Orion shares some commonality with other vehicles like the ICPS or a Centaur. But for the most part, most rockets have a custom software stack and a custom avionics package. Hold on.
I know a lot of people will be excited when they hear the Sonic Boom.
Stupid looking, Baron. I hate it.
And these are going to provide quite a show because you're going to hear those Sonic Booms.
Oh, that's so cool, dude.
Booster landing leg deployed.
That Sonic Boom is great for us.
That thunderclap broke the sound barrier.
That's sick, dude. That's awesome.
Side booster separation confirmed.
Bro,
Just heard the 2 sonic booms here in the room.
that's so good, dude. Booster's just dropping in like, what up? The tunage is what makes that the down. I'm watching it one more time. I don't
I know
care.
a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show because you're going to hear those sonic booms.
Yeah, awesome.
Booster landing leg deployed.
I see it, 3LRD,
Sonic
yeah.
boom is great for us.
Why do you hear 3 sonic booms? Oh. Good side tangent question. This shot shows it pretty well. Grizz, look at that. What do you see? Look at where the vapor is forming. Now, vapor forming on the vehicle does not necessarily mean something is breaking the sound barrier, all right? This is tricky. You touched on the aerodynamic rabbit hole, and it is a rabbit hole. It's bad. Aerodynamics is tough. It's really tough to understand this, but the very, 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 very high level overview, the very simplified version of it is that you hear 3 different booms because there's 3 different parts of the vehicle that are breaking the sound barrier. That should give you a clue. Now, the first big boom that you're hearing is the engine nozzles breaking the sound barrier. What you hear after that is the grid fins, and then the interstage, the back end of the vehicle. So you hear boom, ba boom.
You hear those sonic booms.
Listen. Ba ba boom.
Booster landing leg deployed.
Boom, ba boom.
Sonic boom is great.
Cool, huh?
That thunderclap broke the sound barrier.
Let's freaking go. Oh, dude, hold on. That shot of Falcon Heavy is so good, dude. Bro, look at that. That's a nice looking rocket, man. That's all I'm saying. That's a nice rocket. That's a very nice. It looks real good in that picture, dude. It's just the way the sun was setting when they launched that one. Man, does it look nice. Might help you? Yeah. Oh, nice, Baron. That actually is super useful. Here, yeah, look. Check it out. So, the really easy way to understand this, guys, is that with aerodynamics, okay, there's this thing called the transonic regime. Transonic regime, and once again, this is very, 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 very simple. It gets complicated, all right? But the short story is that in the transonic regime between 0.8 and 1.2 Mach, you can have parts of the vehicle that are breaking the sound barrier and parts of it that aren't. Why? The sound barrier is very, very dependent on something called airspeed. Now, if you were watching DBF, if you watched the Design Build Fly competition that I hosted last week, you'll know a little bit about airspeed. If a plane, yes, F4 Phantom, if a plane is flying, right, through the air, right, and there's no wind, right, more or less your airspeed is similar to your ground speed, right? So how fast you're going is more or less how fast you're going over the ground. Now, if you have a headwind, right? So if the wind is blowing this way into a plane, right? If it's blowing that way, okay? The wind is blowing into your plane. Now, air is moving faster over your wings because the wind is blowing over the wings, but the wind is also blowing the plane back. So your ground speed is going to decrease. Now, keep in mind, this is only when you're kind of near the ground, more or less, right? If you have a tailwind, wind's pushing you this way, you're not generating as much lift, but you're generating way more speed relative to the ground. Airspeed is important to understand. Airspeed does not mean ground speed. Airspeed refers to how fast air is moving relative to the plane. And that is different than ground speed. Ground speed is how fast the plane is moving relative to the ground. Airspeed and ground speed can be different. Now, how does that pertain to flying in the supersonic regime? Well, just like a plane, right? Falcon 9 has air moving over it at different speeds, at different parts. Why? Well, some parts, just like our rocket in KSP, some parts make drag. Right? The grid fins make a lot of drag. They make a ton of it. That's why sonic boom. They make a ton of drag. So by definition, if they're making drag, you're cutting through the air and you have turbulent air at lower pressure. Lower pressure goes at higher speed, right? The speed of sound is very much dependent on how fast air is flowing over a vehicle, right? That's what's important to understand. And it's really, really dependent on airspeed. Okay, it's also dependent on pressure, temperature, humidity. That a lot of that comes into play. This is why there's a lot of variables at play here. This is why aerodynamics is so complicated, right? So when the booster's coming back, you hear some air moving over the vehicle at supersonic speeds that makes the sonic boom, and there's some parts that aren't. Lower pressure generally tends to make air move faster. Well, not tends to, it does. If you have lower pressure, air can move quicker because there's less air to get in the way. How many days would you schedule for each launch? Maddie, trying to plan to see a rocket launch, like a specific rocket launch nowadays is... you're not going to know. Like, the rocket schedules are constantly changing, you know? So, yeah, that's why you hear sonic booms. The big sonic booms you're hearing is the red areas, dudes. It looks like I got it a little bit backwards this time. It's not the fins and the interstage, like I said. It's the engines, the landing legs, and then the fins. Excuse me. I said it was fins and interstage. That's not right. It's the legs. Yeah, see? So you're hearing one big boom and then a small boom right after that and then a medium boom after. The crazy part about this, guys, is that every time you see an area of disruption here, that's where you're seeing that there will be a sonic boom. It's just some of them drown out others. This big one at the front drowns out most of it. How do rockets that aren't on gimbals keep the thrust pointed in the correct direction? For simplification, balancing a pencil pointing up on your finger is almost impossible without changing your finger position. I'm almost impressed they don't spin out. So, Jeff, without gimbal, Falcon 9 without its thrust vector control systems in the first stage and second stage would not fly correctly. It wouldn't fly at all. How Falcon 9 does is the center engine is controlling yaw or pitch and yaw, and then there's two other engines on the outside that control your roll. That's it. And how it controls roll on the upper stage is RCS. There are little jets on the side of Falcon 9's second stage that can roll the thing. They can also pitch and yaw it as well. Baron just linked the graphic up. But yeah, that's the idea, dudes. You hear a bunch of sonic booms because, well, there's 3 different parts of the vehicle breaking the sound barrier. Yeah. It's called the transonic regime. If you can understand transonic aerodynamics, you will make a lot of money in the aerospace industry. Transonics are tough. I don't even bother. I just give you a high-level overview and then I move on. It's really difficult, man. Maybe we'll dive down that rabbit hole one of these days, but that's not really pertinent for KSP because KSP doesn't have that type of aerodynamics in it. So, yeah. Dude, Yeah, if you can figure out a way to if like you can simulate transonics effectively in like computational fluid dynamics simulations, you will make a lot of money in the aerospace industry. That's not easy to do. That's a very coveted thing. Now, you could, but probably not, explain why the RS-25 is the way it is both at sea level and on orbit. It's because it's got a hybrid nozzle. The nozzle's half first stage, half second stage engine. That simple. I want Adrian Newey to design a rocket. He'd probably be pretty good at it, Jim. Remember, Adrian Newey is an aerospace engineer. And if you guys watched the DBF commentary last week, what did Mujahid say? He said, I'm not saying that aerospace engineers are better at everything, but those are his words, not mine. He is a PhD. He has a PhD in aerospace engineering. That's all I'm saying. He teaches it at a university. I'm just saying. He said that aerospace engineers are better at everything. That's all. Those are his words, not mine. That's all I'm saying. I'm just saying what he was saying. I will nod and smile. Yes, that's probably right. Yeah, name every aerospace engine. He seems slightly biased. Yeah, maybe. Hey, Ghost Vera, what's up? Doesn't the air moving in to fill the backside of the craft create a sound? So the other thing is that if we were in like a hot air balloon, right, at like 100,000 feet, and a Falcon 9 flew by, you'd hear the sonic boom. Sonic booms are very directional, Lev. They usually go in the direction of the craft. Think about it. It's sound. So think about like a speaker. Speakers are very directional. Like if I have a microphone, right? And if I turn around, the sound is not going to be the exact same as if I'm talking to you this way, right? See, did you hear the difference? Sonic booms are directional because at the end of the day, it's sound. Just like sound coming out of a speaker. What are the most useful science upgrades in KSP? Epic Dodgy, it really comes down to what you're trying to do. Now, let's go back over and we'll close out this tutorial for this day, right? Our tutorial 1 rocket, we made an expectation of moving 1,100 tons into space or 1,100 tons, 1,100 kilos. We can make it move 1,100 tons. It would need to be a little bigger. I have bigger rockets that can do that. And we achieved it. And that's at the end of the day, really what matters in KSP. Like, what are you trying to do? That's the most important thing to understand. What are you trying to do? If you're trying to move 1,100 tons into space, well, you can make that big of a rocket in KSP if you really want to. Dougalin, I was just wondering the other day if you still stream KSP, and here we are. Good to see you. Hey, man. Yeah, I did take a break after what happened with KSP 2. I took a break, but I'm trying to rescue Kerbals from the moon. All right, Epic Doge, what are you going to need to do that? How did you strand Kerbals on the moon? What happened? Did you crash? Did you run out of fuel? What happened? Not enough delta V to return. So the tutorial here that I showed you was finding the right engine for the job. You need to find an engine that's going to give you more delta V, right? So look in the tech tree or use the engines that you have to figure out what would get you more delta V. You need an engine with higher vacuum specific impulse. If you put an engine on there with higher vacuum specific impulse, you can get a lot of efficiency really easily, and you have more fuel. It's not necessarily more fuel. It's the same amount of fuel, but you can burn it more efficiently, so you have more delta V that way. Oh yeah, I won't bore you guys. Ready? 1, 2, 3. This rocket likes to blow up, by the way. How many engines do you want? Yeah, well, yes. Might work. Stand by for Miko. When the heck did you build this? I don't remember. This is Prometheus. Prometheus gives you fire. Hey, it didn't blow up. Yeah, no, it didn't. Here, does the fairing still work? Huh. Did I build this on the new... did I build this on Canard, or did we build this on the old computer? Because, yeah, this thing has... You know how we were moving 1,100 kilograms? This is 288,000 kilograms. This is a lot more. It's pre-Canard? Yeah. I swear this was last fall. It was on Canard? I think it was. I think it was, to be honest with you. Is that a Saturn section as the payload? Yes. Yeah, it's got a little bit of, you know. You originally built it on the old computer, but it kept exploding until you got a new computer due to lag. Are you sure?
Discovery, go at throttle up.
Autumnus Ducks. Giving KSP tutorials like in the olden days. Pretty good. It works great. Dude, Prometheus works freaking great, dude. Did you see that? That worked excellent, man. That was really good. Like, I'm not even mad. That was freaking sick. Now I'm like kind of happy. And it can lift it? Oh, yeah. It could probably lift more than this. I think my expectation for this vehicle was 300 tons. I'm fairly confident it can be... yeah, no, it can move more than that. Talking about Kermit's mass sent you down a rabbit hole. It's more than twice as dense as a sphere of osmium the same size. The only explanation that fits without immediately converting the planet into a strange matter or a mini hypernova is a primordial black hole. I DM'd you the numbers. I believe you. Yeah, this one's bigger than Neptune, but this one doesn't boost back its first stage. It could, and that'd be really cool if it did, but Okay. How much fuel do I have left over? Oh joy. We have 847 meters a second delta V. This thing could put 300 tons on translunar injection. We could send 300 tons to the moon. So, you know. Draco Pixel, you miss Neptune? Well, this is kind of like Neptune. Okay, hold on. Bonus round for the tutorial. This is Prometheus. You guys, a lot of you guys are saying, "Oh, I think you worked on this during the pandemic." No, I worked on Triton during the pandemic. Triton is bigger. But Triton liked exploding on the launch pad whenever I put it out. It really liked to explode on the launch pad. The motors are overclocked, Lava. It has more than 800. I could send 300 tons to the moon. Triton is big. Oh, you've got to be kidding me. I got a newer computer, and the newer computer has a 9950X3D processor, and what we're really learning is that your performance, your physics in KSP really depend on the physics simulation being a lot nicer. Just excuse me for a second. Don't explode, baby. Stay together. We didn't go up. We didn't go up. Why did we not go up? That's not good. I think those motors were supposed to be overclocked. I don't know if we have the right engines in here. Where's the Cal controller? Those are all Saturn V engines, by the way. This is fine. Okay, I'm gonna go ahead and say that that's not going to do. Yeah, dude, look at that static fire. Oh, yeah, that's great. We static fired. It was mid to late summer, I believe, when you built this. That was the Prometheus rocket. This is Triton. Oh, there it is. Motor overclock. The sequencer is called Go Time. Yeah. It looks like the Cal controller came unbound. I have a way of making engines be a little more spicy. You can overclock motors and make them increase the thrust output. The game starts to get a little weird when it does that, but you know. How many of these do we have? 6 times 3 is 18. There's 19 F1 engines in the first stage. Nice. You know what, dudes? Hold on. Let's back out here. Get the music back on. Yeah, 19 wasn't enough. I have to overclock the engines. I overclock the engines on Prometheus as well. Overclocking doubles the thrust? Well, it really depends on how you tweak the curves. You can make it go triple the thrust. You can make it go up tiplet thrust. You can make it make as much thrust as you want. You just got to know how to do it. Have you done a reusable tutorial in this series? No. This tutorial today was just about basic rocket design and just a high-level overview of the editor. I have all kinds of cool stuff, guys. You could do all kinds of crazy things in Kerbal. Check this out. This is my Ares 7 rocket. Look familiar? It should vaguely look familiar because this looks like nothing in real life, but... Note the bottom. Why is it sideways? I build in the hangar, Delirious. I always build horizontally. You have better camera controls, in my opinion, in the hangar. Do you think we're far enough out of spoiler territory for Hail Mary? Let's wait another week. Give me 1 second. Triton, that's what we need. I don't want Triton R5. That's not what I want. Yeah, you can do all kinds of funny stuff. Have you tried the WASD camera mod? No. Yeah, it looks like I don't have any other versions of Triton loaded up, which is interesting. It's a jet-powered Zodiac. Yeah, yes. It goes fast. Yeah, Dan, well, I got you. I don't think my mod's got it, but... Ah. Here it is. These overclocked? Nope. I want an overclock. Yeah, reusable tutorials tend to be a little bit more difficult. If you guys want to see me, well, at least attempt to land a first stage, just let me know. Let's try Triton R1 while we're here. Let's see. Does this one have the overclock? What the hell was I doing here? Nope, none of them are overclocked. Interesting. Yeah, it ain't gonna move that. But yeah, Triton is, Triton was the rocket, guys, that was the sequel to the Neptune rocket for the people that like the old saves. Triton is by far Triton and Prometheus are the two biggest rockets I've made. I really never saw the need to make anything bigger. Triton is a freaking monster. This thing can move. It has a 10-meter fairing. You can move whatever the hell you want. Anything you could fit in that fairing. What about husband? It's bigger. And husband wasn't a carrier launch vehicle. Pretty good. kind of want to just... Can you give me a second? Just... I need a second to... If we just take this and we make the thrust limiter curve go off the page, yeah, 195. That'll do it. And then we just copy that curve and then just, you know... just paste it a bunch of times. Now they're going to make 195% thrust. You know, as a treat. How did you build something this big? I just used fairings and struts and clustered fuel tanks, dude, to make a bigger core. Think like Saturn 1B in real life. The Saturn 1B's first stage, the Saturn 1 is just... all that is just a bunch of Jupiter and Juno fuel tanks from the Jupiter and Juno rockets, just duct taped together. Well, bolted together, but you get the idea. Jay Praga, I am a consultant for Kitten Space Agency, dude. I'm helping them make it. Oh, I know what it is. Don't worry. All right, don't explode. Don't explode. Right on. Okay, ready? 5, 4, 3, 2, 1. Yeet! Nope, still not enough. Almost enough. We'll go up eventually. It was at this moment that he knew he screwed up. Get down! Game. The engines are still intact. Yeah, Night Skull, it's pretty good. Yeah, some parts went up. Yeah, exactly. How about we just take a little bit of fuel, you know, off the top? That'll get us to go up. Yeah, that's smart reuse. Yeah. Yeah, we grabbed turn a little too early. Maybe it's because I was alt-tabbed when that happened. Hold on. Let's just make sure we're in Kerbal. Hello? Yeah, physics easing in progress my butt, dude. Well, it was cool while it lasted, but yeah, it seems like the game doesn't like that rocket anymore. That's what was happening before. I don't know why that didn't happen. We'll call it garbage collection or something. But yeah, that's Triton used to work. It doesn't no more. We had an S4512 fuel tank up there for payload, and the S4512 is 288 tons. That's 288,000 kilograms. Prometheus. Hell yeah. Yeah, so you can build big rockets, dudes. Prometheus can move the same amount into space, which is pretty cool. How many megatons to orbit? 0.28. Right? No, I don't know. But yeah, it's good, man. Hopefully y'all learned something. You can do all kinds of interesting things.
Discovery, go and throttle up.
89-month resub. Thank you. The problem was that you removed some mass, but that was the only thing that changed. Yeah. Interesting. Is there a KSP SLS building in the docket? I think we can do that on Friday. So once again, fellas, I'm taking tomorrow off because it's my wife's birthday, and I've been basically away for the last 3 weeks between Artemis and the DBF competition. So, yeah, I'm going to take a day and spend it with Brimo. But on Friday, we can keep working on it for sure. What I was working on, King, was here. Let me show you. Yeah, Livin, we did adjust the mass. That you ain't kidding. Yeah, XJ, something like that. What did I want to show you? Oh, yeah. So in order to make an SLS, I'm going to need a 5-segment booster. So in order, we need a test vehicle to make a 5-segment booster, don't we? So, you know. Yeah, no. When do you plan on canceling the program to save 30 billion Kerbucks? Shut up. Didn't you have some sort of near future stuff, like a rotating craft that generates gravity or whatever? The near future thing, it's not really near future. Happy birthday to Brimo. Nice. Put a Taurus capsule on the top. Yeah. Yeah. Something like that, man. I don't think it's in here. Oh, maybe it's under project and it's the endurance. Yeah, the endurance is pretty cool. I guess the heat shield jokes aren't valid anymore. No, that heat shield worked great. What the heck is that? When did you build this? This was my Grand Tour vehicle that we built to send off KSP 1 in style. We ended up not using it because everybody decided to go on vacation, and Kerbal 1 we still just play Kerbal 1. Is this a space station launcher you're making? The other vehicles, yeah, Priceless, you could use those for whatever. This is a grand touring vehicle, so it's designed to be able to just go to every planet. You can go wherever you want with this thing. We never really figured out the stability systems, so I never really ended up using it. I'm debating whether we should show it. So what are you making tonight for dinner? I don't know, I haven't decided, dude. Nice. Steak? Was it supposed to be built on orbit? No. Endurance can just fly up into space. Here, how about we don't put anybody on board, like, ever. He's gonna make mac and cheese and dino nuggets? How many parts is it? 400, 500 parts, maybe? Would love to see you revisit it. Pigzig, give it another week. I said about a month, a little bit more than a month for Project Hail Mary spoilers. We'll build the ship from that book. I'm not gonna say what ship, because spoilers and stuff. But yeah. Wait for it. Yeah, Matthew, I did. Wait for it. All right. There we go. Accelerating this fast up here might prove to be a little bit troublesome, so we should probably stop before this aerodynamic forces rip this thing to shreds. Oh, too late. Looks like we ejected the warp core. Problem is, this doesn't have that. We got a problem. Time to fly a brick. Yeah, Orson, I don't think that's gonna... Oh, that's bad. She's coming apart at the seams. Yep, nope, that's bad. We might survive. Like, maybe. Might need some duct tape. Yeah, it'll buff out, dude. I'm not worried. So the Endurance is a Grand Touring ship. When it does work, this thing can fly up into space. It uses Kraken drives. There's a way... Please... That's not gonna end well. Oh my goodness. Hey, some people would have survived. Not the people in there, though. They're about to have a bad day. Nice. Yeah, that thing has Kraken drives in it, and if you guys are familiar with like the Epstein drive from The Expanse, yeah, it has that. That's a good way of saying it. I designed this ship to be able to fly Brachistochrone trajectories in KSP, so you can go wherever you want, as fast as you want, as long as the hull of the ship can take that much force. We do have limits to how much the thing can take before it really starts to get angry. Probably should restart KSP before we fly this thing again if we do that. But yeah, it is a full spaceship. And the cool thing is that it can land. The idea is that it can land vertically with the landing engines, right? And you can mine resources off of planets to resupply. It can refill itself. Can I teleport it into orbit and show you? I could just make it work. Yeah, it has like a, docking bays on the sides and whatnot. You can... And then I have 4 bays in here. It's kind of loosely based off of the Donager from The Expanse. Loosely. Yeah, you got 4 cargo payload bays up there. How long did this take to make? I made this in a couple of weeks. You got science processing labs. There's enough room for all kinds of Kerbals. You have your main fuel tanks for your engines there, and yeah. The reactor room for the drives is here. These are the drives. There's 7 of them. And what the Kraken drives essentially do is they crunch landing gear. They crunch landing gear inside of a payload bay. And what that does is KSP is using PhysX. KSP is using the Unity engine, and the Unity engine uses PhysX for its physics engine. So there's no bump stop on a spring with PhysX with PhysX package. So long story short, right? What happens if you compress a spring? Like in real life, you have a spring and you compress the spring, there's a maximum amount of compression, right? You can only compress it so much, right? But it's the more you compress it, the more force you're going to need to compress the spring, right? Right, you gotta have more force to compress the spring. There's no stop to this in KSP, so you can inversely compress a spring in KSP. You can inversely compress the springs on the landing gear. And instead of pushing with more and more force to compress the spring, once you push past it and you have negative spring compression, it creates an accelerated force. Because Unity. F equals minus KX. So, provided you have power and stability, right? You can make a ship that can accelerate till the end of time. Like, you just need electrical power to keep compressing the springs. So yeah, this uses negative spring compression force. Negative spring compression force is not a thing in real life. There's no bump stop to a spring. You could just keep compressing it until eventually it inversely compresses and then it creates acceleration. It's called the Kraken drive. Yeah, Kerbal math. Yep, there's boy math, there's girl math, and then there's Kerbal math. You prefer the docking port Kraken drives? Why? Those aren't any fun. Here, if you want to see it working in action. Oh, no, that's... Yeah, we don't want that one. That one is... Yeah, we don't want that. How does one figure that out? I don't know. Oh, very nice. Yeah, if you're newer to Kerbal, there's this thing called the Kraken. You got to remember, Kerbal's a game that's 15 years old. It came out in 2015, but it was in early access as early as 2011, right? There's a lot of glitches in this game. And every glitch that's in the game is attributed to a mischievous entity called the Kraken. The Kraken's always lurking. What this thing does is it utilizes that same mischievous energy and turns it into a drive. All right, let's try to do this one more time. One more time. Let's see if we can get endurance flying. It's I would call it downright malevolent, yeah. Yeet stick. Yes. This thing has 7 yeet. It will not yeet sticks. The finalized design that we wanted for endurance was the yeet brick. The reason why is because it uses the payload bay to crunch the landing gear instead of hydraulics. The payload bay is much easier. So this has 7 yeet bricks in it, and it's enough for it to take off. It wasn't working exactly right. And I do believe that's because Kerbal's garbage collection is getting annoyed with me, because Kerbal is using 13 gigs of memory right now. The yeet brick doesn't necessarily have any more or less stability, or more or less specific impulse, but all right. Does this mean KSP needs a reboot? Most likely, yes. Give it some time. Takes a second for the drive to spool. Come on. Yes. Yes. We have harnessed the power of the Kraken. Shoot.
Sir, I thought you didn't please, sir. I thought the radar, sir.
You don't need that, Private. We are right here to...
I thought the radar, sir.
I'm having trouble with the radar, sir. I lost the bleeps, the sweeps, and the creeps. All right, increase power. More power. More power. So you got to be careful. There's really no tell about when, like, this thing will take off. Like, sometimes the Kraken drive just gets really angry at you and decides to accelerate you to Mach chicken, which is what happened before. Yes, that is a technical term. So yeah, we just got to be careful here. Especially when you're in atmosphere, that could end very poorly. Like last time. Give it a little more. You didn't bucket the throttle. How do you change the power or thrust of the drive? So Kerbal Physics, what I do is I have a Cal controller that's controlling the deploy limit and I have that bound to a key, we can increase the deploy limit. Actually, decrease the deploy limit and cause the payload bay doors to close. When they close, they start inversely compressing the springs, which is what's lifting this like 1,000-ton behemoth up into the air. But if I accelerate too fast, like what I did last time, it'll kick us into overdrive and the whole back of the ship will come apart because of aerodynamic forces. Stay together. Stay together, baby. Stay together. You're all right. You're all right. All right, dial in a little bit more. Increase the compression rate. You got to be careful. This thing gets really finicky when you're close to the ground. When you're up in space, it's not nearly as temperamental. But we got to get up into space first. Have you read Orbital Space: The Theft of Fire yet? No. How far are we from this tech in real life? Inversely compressing springs for spacecraft acceleration? I don't know. Maybe when Nancy Roman launches, when the Nancy Roman telescope launches, we can learn something about antimatter and actually do something like this in real life, perhaps? What's up, Predominant? Oh my goodness. Oh my goodness. It's fine. It's okay. We're all right. Crank it a little bit more. Oh, I'm afraid the Kraken's gonna take it. If the Kraken takes it, you'll know. Oh, there it goes. Oh, God. No, slow down, slow down, slow down. That's too much. Ah! Ludicrous speed. I didn't want it. I didn't want it. Shut it off. Shut it off. Scram, scram, scram. Oh, we are going to die. Okay. Oh, I actually got it under control. We're all right. Slow down. She's gonna jump inside the city. Ma'am, slip space rupture off the port bow. She's gonna jump inside of the city. Green light to engage. I didn't hit the abort button. I have an abort to disengage the drives immediately. I didn't do it. I throttled this down and we were able to get into the throttle bucket before we accelerated to death. Grass, trees. Grab turn? Hello? This is fine. Actually looking like a pretty smooth ascent here. Yeah, this isn't part of the tutorial, just in case anybody's wondering. This is very late game, high Kerbal meta gameplay. This is flex? No! 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 Swear! Never do that. Kraken drives, nerdy astronaut. This is, yeah, Kerbal graduate school. What's the closest to the Kerbin sun you've been? I've crashed into it. 3026, yes. Not the most efficient trajectory here. Let's try to optimize. You have to land on the sun at night when it's off. Yeah. Isn't that supposed to be hard? I did it with a Kraken drive, dudes. I don't even remember when I did that. I don't even know if I did that on stream. Maybe I did that off stream. Have you heard of Geometry Dash?
Go at throttle up.
No. Hey, nerdy. Been some time and a name change since I shared some Prime love here. Yeah, what was your name before, nerdy? Because I know you've watched the stream before by what you just said. Kiggy. Oh, yeah, all right, man. Freaking nerd. I mean, hi. All right, almost there. This is the drive at extremely low power, by the way. We have a periapsis. Throttling back. Drives off. We're good. Okay, the Endurance is in space. You know what would be really cool? I have solar panels for this thing, and the solar panel array is there. I kind of want to give this like the solar array wings that Orion has, so the solar panels can like move backwards. That'd be kind of sick. But then again, the Kraken drive might break them. What's the control surface in the front for? So Isabel, the same thing that I use to make the drives go forward and back, I use to steer the ship at higher speeds. I have a control surface there that's compressing landing gear, and the control surface is just bound to pitch and roll, and it compresses the landing gear, and I have Kraken RCS. Adding saws would be fun. I agree. Side-scroller game where you jump over spikes and blocks. It's pretty cool. I think you'd like it. Scrollers really aren't my cup of tea, dude. But yeah, that is kind of cool, though. All right, Moon. Want to push the drive? When did you figure out Kraken RCS? Kiggy 9595, a longtime viewer in chat, is actually the one that figured it out. He incessantly annoyed me to put it on this thing to make it controllable until I finally obliged and it actually made the vehicle better. But don't tell him that. It'll go right to his head. Don't tell him that. Clipping that. You filthy, smelly butthole of a person. Okay, gonna be a second until the moon comes into view. We gotta make sure that when we push this drive to maximum power, we gotta make sure when we push this thing to maximum power that there's not a planet in the way, or else we'll crash into it. All right, how fast do you want to go to the moon? We can go to the moon. We can do a home and transfer. And we do a home and transfer with the engine. It'll take about 6 hours in real time. Is the propulsion drive also the landing leg trick? Yes, I have yeet bricks here. That's what we call these drives. There's 7 payload bays here, and each payload bay compresses a stack of landing legs. There's 10 landing legs per yeet brick. Engage. Gotta wait for the moon to come over the horizon. It's better if you just point at the planet and then go. Because this thing, let me tell you, she moves. Can it Kraken land SpaceX style? Yes. That's what these engines back here are for. Those engines are to land it. You're going to see Alnitak up close? Huh? The fastest I've ever made anything go in KSP was done with a Kraken drive. We went, what was it, guys? 1% C? El Dorito. Hi, Brimo wants Dairy Queen. Alnitak is one of the 3 stars in Orion's belt. If that was in the game, we could get there with this. I'm just waiting for the moon. Okay, bye. Who sent you? Who sent you, Dorito? Are you setting me up? Are you setting me up? Who sent you? Who are you? You setting me up? Look! Okay.
Discovery, go at throttle up.
All right, we'll wait for the moon to get over the horizon.
Discovery, go at throttle up.
You're wondering, the light that you see on my face is Earth shine. And that is the beautiful Earth.
Give it, man.
Like if anything isn't making
In
sense,
case you're
give me a holler.
wondering, the light that you see on my face is Earth shine.
Good. Good.
And that
Bro.
is the beautiful
Holy sh!
in the
I am trying really hard not to curse right
Like if anything
now.
isn't making
In
sense,
case you're
give me a holler.
wondering, the light that you see on my face is Earth shine. And that is the beautiful Earth.
Hang on. I got a song for this. I got a song for this. Dude, that's so cool. Nice green screen? How can you see my green screen? It's chromed out. How? Yeah, of course I'm using a green screen. What do you think? I'm actually in space? You feeling all right? It was a joke calling the Artemis mission fake, bruh. Yeah, no, I got it. I got it, Hazmat. I didn't laugh, but I got it. No, I got it. I got it, dude.
In the window.
Like if anything isn't making
In
sense,
case you're
give me a
wondering,
holler.
the light that you see on my face is Earth shine. And that
Rick, that's cool, dude. Oh, wait, we're waiting for the moon. That's right. Oh, there it is. All right, let's just give her a little bit of a turn here. You know what we need for this? This is what we need here. Okay, let's go. I know, Drew, that would be sick, right? Oh no, look, we had a transfer. All right. We're at 5 Gs of acceleration. That's about 50 meters a second per second. That's pretty fast, dude. That would hurt. You'd feel this. You gotta hit the juice. Oh, yeah. How you doing it with no throttle? Kraken drives, baby. Oh, the engine room's getting a little rowdy. You see that? Home and transfer? We don't need no stinking home and transfer. You guys want to get shorter? All right, ready? I really don't know what the ship's gonna do past 5 Gs. That's really where we need to keep it and just not go any further. You know what? Yep, I am going to chicken out. Let's just keep it at around 5G acceleration. We're on a collision course. There we go. All right, we gotta just give her a quick. Just give her a quick bump. Oh crap, that just added 53 years for that little maneuver. Hang on, chat. Hang on. It's all right. We're good. We'll be all right. "32 minutes to the moon. And we're still accelerating. We're crossing 6,700 meters a second. Five G sustained for, yeah, like 5 minutes now. That would hurt. That would hurt. You would not be happy at this point. Do what? I don't know what you're talking about. Lunar encounter in 22 minutes. What am I doing? Breaking the light barrier. Yeah, we're gonna have to need a lot of time to stop here, because if we don't give ourselves encounter should be enough time to stop, Yarg. Considering I started accelerating like right there, encounter should be enough time. If I don't hit the brakes quick enough, we will just splatter into a bajillion pieces on the moon. That's the thing about these Rakistachrone trajectories. You gotta give yourself time to slow down. Is there enough time for us to stop by Dairy Queen? There might be. Who sent you? Are you setting me up? Are you wearing a wire? Who sent you? Now hear this. Ludicrous speed. Go! Oh no, I want this. This is the one we want. Right here. Crossing, we're 9,500 meters a second. What engines are these? They're Kraken drives, Drew. So, once again, Normally, I don't like sharing the secret sauce, but we have a new crop of Kerbal viewers here. Now, or Kerbal viewers and Kerbal players. Now, I would advise you guys to not go and make this. These things are really temperamental, and you'll kill someone. It took a lot of explosions to get this drive right. What this essentially does, dudes, is in Kerbal, every landing gear has a spring, right? You have a spring with the landing gear. Pretty straightforward, just like you'd have a spring on a regular car, right? A spring in real life, you can compress. And there is a finite amount of compression that you can get with the spring, right? There's a finite amount of compression that you can get with the spring before you could just keep that force there and the spring will stay compressed. In Kerbal, there's no limit to how much you can compress a spring. So you're going to need more and more force to compress said spring, right? And you can actually create inverse compression in Kerbal. You can make inverse compression. If you crunch a spring past its full compression point in KSP, you can create acceleration, which violates a couple laws of physics and probably thermo as well. But you can use it to make not faster than light drives, but for all mankind, the expanse, stuff like that, you could do that. What was the name of the previous song? It's called The Vastness of Space. This one. If you compress it far enough, can we go to No. Spinala Red. What's up, Max?
No throttle up.
Charles, what's up, dude? 22-month resub. How's it going? We are currently hurling at the moon at 12,000, almost 13,000 meters a second with a ship that has a mass of 2,300 tons. Everything's going great. How about you? What were you up to, Max? Last. No, I don't listen to you. Thanks to S-Master for the base plate, me working for the model, and yourself for the inspiration. Yeah, you guys did invent this, but I forget who came up with the payload bay idea. Whoever came up with that idea, yeah, it was collaborative, but yeah, it was pretty good. Are you there yet? I gotta pee. Bro, do you see how big this ship is? We're accelerating at 5G. There's a toilet on board. Now, when you pee, that stream's gonna go real quick into that damn toilet. So you better learn how to piss on Jupiter, all right? I started it with the shenanigan. Kraken drives go back to the earliest parts of KSP, dude. Imagine trying to use a urinal under 5G. Yeah, that's like 50 meters a second per second acceleration. So, 15 kilometers a second. How hard would it be to drink water? You'd go to drink it and it would just splatter all over your face, dude. You'd go to drink it and you'd be just like pouring it out. They're fully juiced. How's the bubble wrap? Control, can you give me a reading on the bubble wrap, please?
Copy. Bubble wrap nominal.
Thank you, Control. Can you share the link for the music? Of course. Welcome back. We are still here. They're still in space. It's been 16 and a half minutes in game since we took off. He's beamed right out of your regular intervals like in Star Trek. Don't you worry. Oh. Yeah, if you guys wanted to grand tour with this thing, I'd do it. This thing's pretty neat. Probably want to turn and burn. Give it a little bit longer. You prefer the Donager? This is close enough. It's so easy. I could double that. I could do that if I felt like it. We'd need to carry some landers or something with us. I'd like to remind everybody, this is not part of the tutorial. This is me having fun with one of the ships that I made. What's time to SOI encounter? 5 minutes? All right. Turn and burn. .3 kilometers a second. Okay. Turn and burn, cowboy. I'm telling you, you gotta be very careful with this thing. You could blow up the ship. The Kraken drives can get very angry if you push them the wrong way. And the Kraken RCS gets really pissy with you if you try to do a maneuver real fast. So, like for the Expanse fans, if you try to do a Razorback with this thing, it'll blow it to pieces. Many Kerbals died to bring you that information. Which song was Waiting for the Sun? It's called Waiting for the Sun. It's off the RimWorld soundtrack, dude. These ones don't, actually, Yarg. These ones don't get that angry. This one is, this one doesn't do that. This one will work wherever, dude. It'll work at Elu. You weren't here for that part. Okay, re-engaging for deceleration. Drive is engaged. 1G. Decel. 2Gs. Gotta be careful about SOI transition, though. Yeah, and if I don't slow down in time, we get ejected into the sun. Well, solar orbit, but we could say it's the sun. That sounds cooler.
Discovery, go and throttle up.
Pushing it up to 5. Hey, Cody. We're on a mission from God. They're not gonna catch us. We're on a mission from God. All right, 5G decel. Yeah, paradox it is. How does KSP handle Delta V enough to escape the sun? You can escape the sun, but once you escape it, there's nothing out there unless you mod something in. 17 kilometers a second and decelerating. What would happen to the human body? 5G sustained, Keen Bob? Yeah. 5G sustained for like 20 minutes like this would... You would not be having a good day. You wouldn't be having a good day. Your heart would have to, your heart's down here, right? And guys, I'm not a doctor, I just know the basics, right? So your heart is a pump, right? It's pumping, it's a muscle that goes like this. What it's doing is pumping blood. Where a lot of that blood goes is up here, right? And up into your brain, right? This thing needs a lot of power. Well, not power, it needs oxygen, but you get the idea. So if we were standing, right? If we were standing like this under 5G, right? Your heart could do it. It would be okay for a little while, but your heart's gonna have to pump faster to keep the blood circulating to your head, all right? If we were standing on this ship, and if we were like standing on the long axis, like picture the ship as like a skyscraper, that would work, right? But your heart would need to really go to defy the G-forces. You're dealing with 5 times the force of gravity. Your heart, we evolved over millions of years for your heart to be able to deal with 1 G, not 5. Not 5. So, I mean, if you were standing, you might be okay. If you were sitting the right way, you might be okay, maybe.
Oh, this is space.
Hey, Valkyrie,
I'm in
get
space.
to the sub, thank you. You would, but eventually your heart would just start going so fast, it's like think of it like a car engine. Like a car engine will work and it'll make power, but if you just put it in the red line, you put your foot to the floor, you put it in the red line all day, eventually something's gonna break. That's what your heart, that's what happened to your heart. Your heart would basically redline. That's called cardiac arrest. Yeah, it's not pretty. We already solved this problem with the way astronauts go to space, but they pull 3.5 Gs sustained on the way up for like maybe a couple of minutes. This is 5 Gs for like 20 minutes. Humans you might be okay. You might be fine. If you had high cholesterol, I'd be worried. 1.5 would be fine, Hip. You wouldn't even notice that. Is there a reverse version of artificial gravity? You can go higher with spinning rings, but can you take it lower? A deceleration? Yeah, just stand on the outside of whatever's spinning ship. Yeah, John Stapp pulled a lot of Gs, but he didn't do 5 Gs sustained for like 20 minutes, dudes. That's why you launch on your back, yeah. I mean, if you're lying down or on your back, yeah, it's okay. Like, you'd probably be all right here. I mean, it would hurt. You'd feel it. It would hurt. It'd feel like you were being crushed. Like, think about it, dude. So, like, I weigh 250 pounds, right? 5 times, right? That would be like having an elephant sit on you. That would hurt. That would hurt a lot. Oh, here it comes. Oh, it's going to be a lot. You know, like, that would hurt. You'd feel it. Oh, you'd feel it. Just get some pillows. Ah, yeah. Yeah, if we were accelerating at like 10G, it would be like having a car on you. Yeah. It would be like if my Dodge fell on me. That would hurt a lot. Yeah. Sit on me. No. I thought that was what the bubble wrap was for. Oh yeah, we should probably check in with Control to see if the bubble wrap's good, just in case. Hey, Control, this is Project Endurance. What is the status of the bubble wrap? Can you confirm that bubble wrap is nominal?
Copy. Bubble wrap nominal.
Thank you, Control. How many G's until you get crushed? Past 9 G's is where stuff would start to... Colonel Stapp is the one that taught us this. Past 9 G's, your body starts to not do good things. You start to damage things. Things start to get crushed. You start popping blood vessels, which is not great. It's not really good for you. I mean, guys, it's a testament to us evolving in the gravwell that we did. Earth is, for Earth's size, the gravity is pretty good. It's pretty dense for its size, comparatively to other planets in the solar system. Yeah, we have one hell of a gravwell for a planet this size. And that, makes us a little bit more resilient. It's why, like, the Apollo astronauts, when they were when they're around on the moon, it's why it looks so weird, dude. They look so weird when they're hopping around on the moon. It looks strange because we were designed to work in 1G, not 1/6 G. That's why it looks so weird. That's why I trip up and it looks really, really strange. I'm getting Kerbal Space Program today. Any tips for beginners or mods I should install? So, Sim Captain, what I would say is go back in this VOD, dude. I at the beginning of this video, this stream, I did a pretty high level overview of Kerbal and what you should be doing. In terms of mods, I have a couple of visual mods, dude, but I mostly play the game stock to teach people. Yeah, Ryan, for sure. All right. We have to completely disengage the drives through SOI transition or they break. We have to completely open up the drive. We can take momentary decelerations, Ryan. Any Formula 1 driver that's gotten in a crash knows what I'm talking about. You could take a lot of G's instantly decelerating. Our body is pretty damn robust in that capacity. It's just sustained is not the same as instant. 360 G impact, your body can take that if you're in shape. It has to be for a split second though. if it's any longer than a second deceleration at 360 Gs, you're really gonna have a bad day. Your paint on the freaking whatever you hit. Drives are disengaged. Yeah, with the Expanse, you don't need to accelerate that fast. 1G acceleration will get you to Mars pretty damn quick. Like, you don't need to do 5G, but then again, they did that when they were doing maneuvers and stuff. I mean... What is going on? I just got here. We're entering lunar SOI here. And we're going 4,700 meters a second with the Endurance. This is my Grand Touring spaceship. It's designed to do the Grand Tour, hit every planet and every moon. How many Gs was the Artemis re-entry? About 3.5, Keenbop. 1G would be, yeah, Tessa, like if we could make something accelerate at 9.8 meters a second per second, oh, we'd be good, dude. Like, the problem is that, you know, getting something to accelerate at 9.8 meters a second per second for that long is kind of a little bit of a problem. That's really where we need to be figuring out stuff. Chemical rockets are all fine and dandy, but yeah, if we had a drive that could do this, we could just tour the solar system. Like, tour the solar system, that's no big deal. Yeah, I'm getting a little bit of coupling. That'll do. Close the reactor, Quaid. Are the drives uncoupled? Yes, they are. We can coast for a little bit. That's good enough. Okay, re-engage the drives. Drives are engaged. Yeah, note that we're not time warping and that moon is getting big awfully fast. This is the endurance, guys. You could tell because of the way it is. Really wish those drives would engage. Yeah, I did not build this today. This is from a previous version. Come on. Moon. There we go. Drives are on. Approaching 4G decel. 4, 5. We'll really push it here. 6 G's deceleration. 7. Oh gosh. Kraken's starting to get angry. Yeah, okay, I'm not pushing it past that. That's just asking for death. Dude, did you see the camera? Dude, the camera was like, that's that made it very unhappy for a second. We probably shouldn't do that for a long period of time. What exactly are the drives doing? Those drives are compressing landing gear. When you compress landing gear, you can essentially compress the spring infinitely. And if you start pushing the spring into negative compression, it creates an acceleration. It's a glitch in KSP, but I built a spaceship around that glitch. And yeah. We flew to the moon in 30 minutes with a 2,100 ton ship. We call it the Kraken drive, Chris. Yeah, because the Kraken is, yeah. Yeah, we just went to the moon in basically real time. I did time warp a little bit, but did get us into a nice polar orbit around the moon, though. You don't own space? NASA does. We're still decelerating at 1G. We will still get ejected into the sun if we're not careful. How much delta V with chemical rockets? This would have been on par about 40 kilometers a second delta V hit to do something like this. Sorry, I meant how much does the endurance have? Rough guess here, probably 50 million kilometers a second. Rough guess. Yes, 50 million. No, I'm not. No, I didn't. lose a decimal point. Yeah, like 50 million kilometers a second, probably something like that. This thing could go light speed in KSP. Going light speed in KSP doesn't do anything because there's no relativistic physics in KSP. Oh. Hold on. We've captured the moon. Drives are engaged. Chemical drives are engaged. Sorry if that scared everybody. Okay. This is why I have the regular engines. It's much easier to do it with the regular engines here. Okay. It has ISRU, Yard. Yeah, it has ISRU capability. You can put whatever you want in it. You land it vertically. And, yeah. That's why the radiators are there, dude. We have twin ISRUs, double redundancy. I have 2 drills. Actually, I have 4. We have 4 drills, and, yeah. I wanted to build more fidelity into this design, like building doors here, like so you could open and close the payload bay, but it wasn't in the part count budget. But with this computer, that don't matter. Yeah, no one's on board. Oh, Earth set. Yeah, it's 1,000 parts, Tessa. If I restarted Kerbal, it'd probably be better. You know what? I'm gonna leave Endurance here. Maybe we'll send people out to the damn thing. Or we could just revert and maybe send people later. Or we could just send it back to Kerbin and then get people on it that way and bring my shuttle up and dock the shuttle to this stupid thing. Yeah, we'll leave it. All right, guys. So, I hope you enjoyed the tutorial and then some shenanigans after that. I told my wife that I would make her dinner. So, I'm going to do that. I may or may not come back and play Battlefield. All good Kerbonauts cook their ladies dinner. Can you make us dinner? No, you're not my wife. What's for dinner? I don't know. I haven't decided yet. Send back to Earth Prometheus style and Mark Watney some crew on board. Maybe I'll come back later tonight for some Battlefield. Who knows? But anyway, I hope you guys enjoyed the Kerbal tutorial help desk day thingamajigger. Maybe we could get more into other tutorials with like docking and stuff if you guys wanted to do that. We got 2 launches tonight. What do we have? Oh, there's 2 Starlinks. Don't come back for BF6 early night, then give Brima a nice birthday tomorrow. You need to learn docking? All right, we can do docking. So tomorrow I'm gonna take the day off because it's my wife's birthday. And I've been kind of trying to take it easy this week to recoup, which is why I'm like stopping early. I usually stream till about 10 p.m. And sometimes even more. My streams usually go 10 to 12 hours. SpaghettiOs. Yeah, mac and cheese and dino nuggies. That's what I'm making my wife for dinner, sure. Maybe you can make the Endurance spin and then dock to it. Brimo is turning 29 tomorrow. Yeah, 29, right? Because it's just weird. Weirdest thing, dude. She's been turning 29 for like, I don't even remember. I don't even know how long. Weirdest thing. Yeah, I know. She was 29 last year, and then the year before that, and then the year before that. It's just so strange. So once again, I'll see you guys on Friday. On Friday we'll rebuild. We'll keep building out that Ares build, the Ares 1X build, and yeah, we'll dock something to it. It'll be fun. Yeah, I know, Yarg. It's so strange. She's traveling at 99.99% the speed of light. It's science. It is science. Yeah, no, yeah. You're 42 for like the 12th time in a row. That's so strange, dude. What are your relative speeds? That might explain the time dilation. I don't, yeah, you know, we'd have to do the math. All right. I might be back for some Battlefield a little bit later tonight. If not, I'll catch you guys on Friday, okay? Thank you very much for watching. I'm sorry about the light week on the schedule. I'm trying to just regain my bearings because for 3 weeks, the life was like, here, have some aerospace. And I'm like, okay, I don't know if I can eat anymore. And it's like, nope, too bad. Here you go. And I'm just like, okay. So, yeah, it's just give me a second to recoup and figure out what the heck's going on. And then, no Battlefield Brimo night. All right, fine. We'll play Battlefield after Flame Trench on Friday. All right, dudes. I will see you guys on Friday. Thank you very much for watching. Have a good night.